Chapter 13th in 10th standard max is statistics. In some state school textbooks, the chapter number could be different, but all states who have implemented national education policy will have same syllabus. So if your state has implemented NEP, then though the chapter number is different, you can use this video for learning purpose. And before discussing this topic, let us do some basics. So what is average? I have given you some examples. You can see average is also called mean. Okay, so average of 1 and 3 is, how do we find? We add both and we divide by 2. Here only two numbers are there, that's why we divide by 2. So 1 plus 3 is equal to 4 by 2 is equal to 2. So average of 1 and 3 is 2. And what is the average of 1, 5 and 9? So we need to add all the numbers. 1 plus 5 plus 9. There are 3 numbers, therefore I'll divide by 3. So 1 plus 5 plus 9 is 15. 15 by 3 is 5. So similarly, average of 7, 2, 4, 9 and 6 is 28 by 5. So here 5 numbers, 5 elements are there, that's why I'll divide by 5. So 28 by 5 is 5.6. Similarly, what is the average of this one? Okay, here you can see there are a lot of numbers. Okay, if I add all these numbers, I'll get 108, and totally there are 24 numbers here, or 24 elements are there. So here 108 divided by 24 is 4.5. Therefore, average of all these numbers, average of this data is 4.5. Now I'll represent all these data in a different fashion. Now you can see here 1 has repeated, 1, 2, 3. 1 has repeated 3 times. So 1 has repeated 3 times. Okay, and 2 also, 1, 2, and here 1, 3. So 2 has repeated 3 times. Okay, and this number of repetition is nothing but called as frequency. Okay, and similarly 3 has repeated 4 times, 4 has repeated 3 times, and so on. 8 has repeated 4 times, and 9 has repeated 1 times. So I have arranged this in column wise, and the second column is called frequency column. Okay, this just denotes the number of times this number has repeated, and the first column I have denoted as xi. Second frequency column I have denoted as fi. So since this is fi, this will be f1, this will be f2, and so on. This will be f3, like this. And this here 1 I have denoted as x1. So the next one will be x2, x3, x4, and so on. Okay. Now in the third column I have multiplied this number with this number, that xi by fi. So 1 into 3 is 3, 2 into 3 is 6, 3 into 4 is 12. So I have multiplied everything. Now I have sum up this column, that is frequency column. So sum of the frequency is, I am getting 24. So that one I am representing by sigma fi. Sigma means it is sum. Okay, sum of all the frequencies. Sigma fi means sum of all the frequencies. So that is 24. Now xi fi I have got these values here. Now I'll sum all these values. So sum of xi fi, that is sigma xi fi, is 108. If I add all this, it is equal to 108. So here you can see already I got 108 by 24. Same number I am getting here, 108. Here it is 24. Now mean will be sigma xi fi by sigma fi. So 108 by 24, I'll get 405 only. Sorry, 4.5. So this value is same as this thing. Okay, but what is the difference between arrangement of numbers in this way and in this way? So arranging these data in this manner, in tabular column like this, it's very convenient. So here just by seeing I can say how many times 5 has appeared. It has appeared 3 times. How many times 9 has appeared? It has appeared only 1 time. So just by looking the table, I'll get so much information. But here it is not so convenient. Every time I need to read it. So this is more convenient and easy to analyze, understand, read. Okay, now can I do it more easier way than this? Yes, I can do. So that is called as grouped data. So here you can see in the given data, one occurs 3 times, 2 occurs 3 times, 3 occurs 4 times, 4 occurs 3 times. Therefore 3 plus 3 plus 4 plus 3, it is 13. So there are 13 numbers which lies between 0 and 5. So that one I'll write like this: 0 to 5. There are 13 numbers. Okay. Now 13 is the frequency. Now again, 5 has occurred 3 times, 6 has occurred 2 times, 7 has occurred 1 time, 8 has occurred 4 times, and 9 has occurred 1 time. If I add 3 plus 2 plus 1 plus 4 plus 1, I'll get 11. So there are 11 numbers which lies between 5 and 10. Okay, between 5 and 10 there are 11 numbers. Okay, now these two I'll call as frequency, and I'll sum up these two, I'll get as 24. 13 plus 11 is 24. Now you can see sigma fi, or the sum of the frequency, is same as here. Here also sigma fi I'll get as 24. Now what is xi here? So here xi is the original values 1, 2, 3, 4, 5, 6, 7, 8 and 9. But here we can't take like that. So what I'll do is I'll take the midpoint of 0 and 5. So midpoint of 0 and 5 is 2.5, and midpoint of 5 and 10 is 7.5. So these are the two new xi's. Okay, now I'll multiply this xi with fi. 13 into 2.5 is 32.5, and 7.5 into 11 is 82.5. Now if I sum up these two data, I'll get sigma xi fi. So sigma xi fi I'll get as 115. Now if I divide this data with this data, this sum with this sum, I'll get as 115. 115 by 24, I'll get as 4.79. So 4.79 is the mean. Okay, this is actually approximated mean. The original mean is this 4.5, which we calculated here earlier. So this is accurate, but this is an approximated mean. The reason why we are getting approximated mean here is because we have taken xi to be midpoint of this class interval. Here xi I have taken as midpoint of 0 and 5, that is 2.5. Here it is 7.5, that is the midpoint of 5 and 10. But whereas xi here are all original values, here it is approximated value is there. That's why mean also I'll get as approximated value only. So since though this system, this group data gives approximated value, why do we go for this? That's the question. See, if there are huge data like population of India or a population of a state, the data will be so huge. That time it's convenient to group data like this, in this way, and find the mean. And sometimes we are not interested in accurate mean. Okay, and we'll be more interested to find how many data lies between 0 and 5, how many numbers lies between 5 and 10. That way we'll be interested. That's why we'll go for group data. It's very easy to calculate, understand, and to explain somebody also it's very easy. Let us go through some work examples in the textbook. So in the textbook you can see there is one example. The marks obtained by 30 students of class 10th of a certain school in the mathematics paper consisting of 100 marks are presented in table below. Find the mean of the marks obtained by the students. So here in one row they are given the marks, and in another row they are given the number of students. Okay, so one student scored 10 marks, another student scored 20 marks, 3 students scored 36 marks. Similarly, 3 students scored 92 marks and 1 student scored 95. So same data they have arranged like this in columns. Okay, here you can see one student scored 10 marks, another student scored 20 marks, 4 students scored 60 marks, 1 student scored 80 marks, 1 student scored 95 marks. So same data they have arranged in column wise. Okay, in the first column, marks they have taken as xi, and the number of students they have taken as fi. So now if I multiply this with this, I'll get fi xi. Fi xi is nothing but multiplication of these two. Okay, so after getting all fi xi, I will add the frequencies. So frequency already they have given that there are 30 students, I think so, in a question. So if I add all this, I'll get 30, and if I add all this, I'll get sigma fi xi. Now if I divide this number with this number, I'll get the mean or the average. Now let us see, and that mean is denoted by x bar. Okay, so x bar is sigma fi xi by sigma fi. So this is equal to 1779 by 30. This is equal to 59.3. Now the same data I can solve it in another method, that is by grouping of marks. Okay, now you can see. Okay, now in first column I have written as 10 to 25, that is marks from 10 to 25. Then here 25 to 40, 40 to 55, 55 to 70, 70 to 85, 85 to 100. So these are the marks. Okay, so there are two students who have scored between 10 and 25. There are 3 students who scored between 25 to 40, and 7 students who scored between 40 to 55. Like this we have grouped. Okay, and this will be the new frequency. Okay, 2 3 7 6 6 6 are the new frequency. When I add the frequency, I should get that to be equal to the total number of students, which is equal to 30. Now what is xi? Here xi also will be new xi. Okay, xi will be the midpoint of the class interval. So midpoint between 10 and 25 is 17.5. How do I get this? 10 plus 25 divided by 2 will be 17.5. Similarly, midpoint of 25 and 40 is 32.5. So midpoint of 40 and 55 is 47.5. So I have calculated all the midpoint, and that midpoint will be xi. Now if I multiply this value with this value, I'll get fi xi. So fi xi I have got here. Then I'll sum up all these data, these values. So here I'll get sigma fi xi. This is 1860. So and sigma fi is 30. Now if I divide this value with this value, I'll get the mean. So x bar is equal to sigma fi xi by sigma fi is equal to 1860 by 30 is equal to 62. So but in the previous method, how much mean I got? Mean we got 59.3, but here using the same data we got mean as 62. So why this difference? So in group data there will be some difference, because here in group data we are taking x to be the midpoint of the class interval. That's why we are getting approximate mean. So in the previous method xi were all original, but here it's all midpoint of the class interval. That's why there will be some difference in the mean. Okay, and if we solve by this method is called direct method. Here in direct method there is one big disadvantage. Here you can see fi xi gives huge values. When we multiply frequency with x, we get huge values, and when we sum up also we get huge values. So whenever we get huge values like this, it's we are prone to make mistakes. Multiplication is a tough job, so mistakes could happen, and when we sum up again, here also there could be some mistake, and mean is calculated by this formula. Here it is 62. So to simplify the calculation, there is another method, that is called assumed mean method. So same data has been taken, same example has been taken. So the first 3 columns are the same data as in the previous method: class interval, number of students, class mark. Here one value among the x has been taken to be the mean. So one value we will assume to be mean. So 1 2 3 4 5 6 values of x are there. Among these 6, the middle value is third value and fourth value. Third is 47.5 and fourth is 62.5. So in between these two we can assume any one to be the mean. So they have assumed 47.5 to be the mean. Okay, and in the next column they have calculated the deviation. Deviation is nothing but xi minus assumed mean. Assumed mean is represented by a. So here a is 47.5. So xi minus a, xi minus a is xi minus 47.5. So here 17.5 minus 47.5 is minus 30. 32.5 minus 47.5 is minus 15. 47.5 minus 47.5 is 0. Similarly here 15, 30, 45 we get. And when we multiply frequency with di, we get fi di, and that has been tabulated here. And the sum of fi di is here 435. Now we can compare fi di values and fi xi values. See here we got all low values, and the sum also we got low. But in fi xi, you can see these are all very high values, and this is also a high value. So now after this they have calculated the deviation of the mean. So d is the deviation, and the mean of the deviation is given by sigma fi di by sigma fi. And finally the mean is given by this formula. Mean is equal to assumed mean. A is the assumed mean. What is the value of a? We have assumed it to be 47.5. So a plus d bar. So a plus sigma fi di by sigma f. So what is a? A is 47.5 plus sigma fi di is 435 by sigma fi is 30. Finally we get 42 to be the mean. So in direct method also we got in direct method also we got 62, and even in assumed mean method also we got 62 to be the mean. But this method is simpler. It's very easy to calculate, and it is less prone to errors. There is another method to find the mean which is more simpler than assumed mean method. So here you can see same example has been taken. The first 4 columns are same as in the previous step. Okay, after calculating di, we calculate ui. Ui is nothing but di divided by h. What is di? Di is nothing but xi minus a. Okay, so di divided by h. What is h? H is the class size or the class width. What is the class width? Here you can see class width is 15, and it is constant throughout. Okay, class width is 15 here. Here also 15, 15, 15, 15, and 15. So this column, if we divide by that class size, we get this column, that is minus 30 by 15 is minus 2, minus 15 by 15 is minus 1, 0 by 15 is 0, 15 by 15 is 1, 30 by 2 is 13 by 15 is 2, 45 by 15 is 3, and we'll multiply frequency with ui. So we get fi ui. So and we'll sum up all these values. So sigma fi ui we get as 29. And now again you can see the product of fi ui and the summation are smaller compared to the fi di values here. So these values are bigger, and these values here they are even smaller. Okay, now we'll calculate u bar. U bar is nothing but sigma fi ui by sigma fi, and ultimately mean is given by this formula. Mean is equal to a plus h into u bar. So a is the assumed mean. Okay, so assumed mean was 47.5, and h is the class size, which is equal to 15, and sigma fi ui is 29, and sigma fi is 30. So here also we got 62 to be the mean. So in all the 3 cases, whether it's direct method or the assumed mean method or the step division method, we get the same answer. The assumed mean method is easier than the direct method, and step division method is easier than assumed mean method. Here you can see some important points listed. The step division method will be convenient to apply if all the d's have a common factor. The mean obtained by all the 3 methods is the same. The assumed mean method and step division method are just simplified forms of the direct method. The formula x bar is equal to a plus hu still holds if a and h are not as given above, but are any non-zero number such as uy is equal to xi minus a by h. So what it means is, so here assumed mean was this one 47.5. Instead of 47.5 we can assume a to be 62.5 also. We can assume any other values of xi also as assumed mean, but still we will get the same answer. And also here you can note we divided d by h. H is the class interval, so it's not necessary always we should divide by class interval. We can divide by any number which divides all these numbers here, and still we get the same answer. I think many of the things were bouncing for you, but don't worry, when you solve problems one by one you will understand all and you will start remembering, and it will be easy after that. In group data analysis we can find mean in three different ways. One is direct method, the second method is assumed mean method, the third way is step deviation method. In the first method the mean is simply given by x bar is equal to sigma fi xi by sigma fi, where f stands for frequency and x is the midpoint of the class interval. And in the assumed mean method, mean is given by a plus d bar, where d bar is the mean of the deviation, which is given by sigma fi di by sigma fi, and a is the assumed mean, that is will have midpoint, okay, in group data, and the middle value of that group data will be the assumed mean. And in step deviation method, mean is given by a plus hu bar, where a is the assumed mean here and h is the class size of the class interval, okay, and u bar is nothing but sigma fi ui by sigma fi. So you can use any of these three methods and find the mean of the given group data. Okay, if the values of f and x are very large, then calculation, multiplication and all will become tough, because we will have big values for f and x. In those times we can go for assumed mean method or by step division method. So in the textbook there are some more problems here given. Okay, the table below gives the percentage distribution of female teachers in the primary school of rural areas of various states and union territories of India. Find the mean percentage of female teachers by all the three methods discussed in this section. So here are the group data, okay, and percentage of female teachers, number of states. So in 6 states there are 15 to 25 percentage of female teachers, and in 11 states there are 25 to 35 percentage of female teachers, and in 7 states there are 35 to 45 female teachers, like this. Okay, so they have reorganized this one in this column wise chart. Now here they have taken the class interval, that is percentage of female teachers 15 to 25, 25 to 35, so on, and 75 up till 85, and number of states they have put in second column 6, 11, 7, 4, 4, 2, 1. Now x, what is x? X is the midpoint of class interval. So 15 plus 25, 15 plus 25 is 40, 40 divided by 2 is 20. So similarly midpoint of midpoint between 25 to 35 is 30, 25 plus 35 is 60, 60 by 2 is 30. Similarly these are the midpoints of this class interval. Okay, now let us see what they have done. Okay, so x they have obtained here. Okay, now what is fi xi? So f multiplied by x is the fi value. So 6 into 2, 6 2s are 12, 120. So 120 is fi xi here. Similarly they multiplied f with x and they put it in this column, and the summation of fi xi is 1390. Okay, this is sigma fi xi. Similarly, d they have calculated. Before calculating d, we need middle value of xi. So how many data are there? 1 2 3 4 5 6 7. So out of this 7, 50 is the middle one. So they have taken a as 50. Therefore 20 minus 50 is 30. 30 minus 50 is minus 20. 40 minus 50 is minus 10. 50 minus 50 is 0. 60 minus 50 is 10. 70 minus 50 is 20. 80 minus 50 is 30. They have got this d here. Now they have done f1 into d1, sorry, fi into di. So frequency into deviation, 6 3s are 18, that's why we are getting here 180 minus 180. Then 11 into 20 is minus 220 here. Like this they have multiplied f with d and they have put it in this column. Now what is u? U is equal to d by h. What is h? H is the common divisor of these numbers. H may be also the class width. Here class width, what is the class width? 25 minus 15 is 10. So everywhere the class width is 10. Okay. So d divided by 10, they have got this value. So 30 divided by 10 is minus 3. Minus 30 by 10 is minus 3. Minus 20 by 10 is minus 2. Minus 10 by 10 is minus 1. So here 0. 10 by 10 is 1. 20 by 10 is 20. 30 by 10 is 30. Now they have got u. Now here f into ui. So this is ui, this is fi, this into this. So 6 3s are 18, minus 1 8. Okay, 11 2s are 22. So minus 22 here. So they have got all these values. So here you can see in fi xi we get huge value. All these numbers are very big values are there. So here summation also will be a big value. And fi di compared to this column, the numbers in these columns are lesser. Okay, see most of the numbers are lesser compared to this column, and the summation also will be lesser than this only. Okay, here 1390, here it is minus 360. So this is lesser than this one. Now coming to fi ui, here you can see the numbers are still smaller compared to this one. So minus 80, it's all single digit or double digit, and double digit also are very less. Minus 18 and minus 22 are there. Okay. Now summation of this is minus 36. Now you can see this is lesser than this. This is lesser than this. Now computing this one is very easy. That's why instead of direct method we go for assumed method and step deviation method. Now according to assumed method, what is the deviation given by? What is the mean given by? Mean is given by sigma fi xi by sigma fi. So that is 1390 divided by 35, 39.71 we get. And using the assumed mean method, according to assumed mean method, the formula is a plus sigma fi di by sigma fi. So here a we had taken as 50 here, right? So 50 plus sigma fi di is minus 30 by sigma fi 35. So again here also we get 39.71. So in the first method also we got 39.71. In the second method also we got 39.71. And in the third method, that is the step deviation method. So what's the formula? Mean is given by a plus h into u bar. That is a plus u bar is sigma fi ui by sigma fi. Okay. So a is 50. Here we have taken the mid value of this column. Mid value of this column is 50. So 50 plus sigma fi ui is minus 36 here. Okay, minus 36 by sigma fi. Sigma fi is 35 into 10. So here also we get 39.71. In all the three methods we get the same answer. But which is the preferred method? Definitely it's assumed method, and step division methods are preferred method, because see here we get very large values. Multiplication becomes complicated here. Okay, we get big values here, and adding this also or tough job. Okay, and sometimes when we get big values like this, we may do mistakes, but see here, all these values are all small, and doing arithmetic operation on small values are easy, and it's not prone to errors. So assumed mean method and step division methods are best. And here you can see one more problem is there. The distribution below shows the number of wickets taken by bowlers in one-day cricket matches. Find the mean number of wickets by choosing a suitable method. What does this means? What does this mean signify? So here the given data they have reorganized in this form. They have put it in vertical columns like this. So this one they have taken as class interval 20 to 60, 60 to 100, 100 to, and these are the number of wickets. Number of wickets they have put it in first column, and the number of bowlers they have put it in second column. Now what is x? X will be the midpoint of this class interval. So what is the midpoint of 20 to 60? It is 40. So how to calculate? 20 plus 60 divided by 2. So 80 divided by 2 is 40. So similarly here also midpoint is 80, 125, 200, 300, 400. Okay. Now if I add all this, I'll get sigma fi, that is frequency. I'm adding the frequencies. So here this is sigma fi, sum of frequencies. Now what is d? D is xi by xi minus a. So here they have taken mid value. 1, 2, 3, 4, 5, 6 data is there here. So third and fourth are the mid values. Okay, third and fourth are the mid values. Instead of 125, they have taken fourth value as the mid value here. That is a. Therefore, xi minus a, xi minus 200. So 40 minus 200 is minus 160. 80 minus 200 is minus 120. 125 minus 200 is minus 75. 200 minus 200 is 0. 300 minus 200 is 100. 400 minus 200 is 200. Now what is u? D by h. What is h? H will be the class size of the class interval here. Okay, so here actually class interval is not it's changing. Okay, class width is changing. Here class width is just 20. Here here class width is just 40. In the second case also class width is just 40. But here you can see 100 to 150, class width is 50. Here you can see class width is 100. Okay, 150 to 250 there is 100. Okay, so class width is not same, it is changing. So here u they have taken as d by 20. So 20. So whenever class width is same, we could have taken h as that class width, but here class width is changing. That's why they have taken as 20. 20 divides all these numbers. Most of these numbers it's going to divide. Okay, 20 divided by 60. So u is d by 20. That means previous column, whatever values we have, that if we divide by 20, we get this column. So minus 160 by 20 is minus 8. Minus 120 by 20 is minus 6. Minus 75 by 20 is minus 3.75. So here it is 0, 100. Sorry, here it is 5 and here it is 10. Now they multiplied u by f. So this is f, this is u. Multiply these two. They have got this value. So here, what was the problem? We can find the mean number of wickets by choosing a suitable method. So out of these three methods, what are the three methods? Direct method, assumed mean method, and step deviation method. We can choose any method and find the mean. So they have chosen the third method, step deviation method. So in step division method, we'll find u by fi and we'll find u bar. U bar is sigma fi uy by sigma fi. So that is minus 106 by 45. Therefore x bar is equal to, what is x bar? X bar is equal to a plus h into u bar. So a is 200, plus h. So h they have taken here it as 20. So 20 into u bar is minus 106 by 45. So 152.89 is the mean. The next topic is exercise problem. Exercise 13.1. A survey was conducted by a group of students as part of their environment awareness program, in which they collected the following data regarding the number of plants in 20 houses in a locality. Find the mean number of plants per house. So number of plants is given, number of houses is given. That means here in one house there is 0 to 2 plants, and in two houses there are 2 to 4 plants, and in one more house there is 4 to 6 plants. Similarly, in two houses there is 10 to 12 plants, and in three houses there is 12 to 14 plants. Find the mean they are asking. Okay, now the same data I have arranged here. You can see I have arranged in columns. Now the second column will be the frequency. Okay, that means in one house there is 0 to 2 plants, and in two house there is 2 to 4 plants, like this. And third column will be my xi. So xi will be the midpoint of the class interval. Okay, class interval is nothing but the number of plants. So what is the midpoint in the first one? In the first class interval, what is the midpoint of between 0 and 2? Midpoint will simply be 0 plus 2 divided by 2. So 2 divided by 2 is equal to 1. So xi will be, x1 will be 1 here. And what is the midpoint of between 2 and 4? That is simply 2 plus 4 divided by 2. So 6 by 2 is equal to 3. So midpoint between 2 and 4 is 3. Okay, there is another method. Every time we can't calculate like this. What is the class size here? Class size is 2. For example, the first interval is 0 to 2. So class size will be 2 minus 0. 2 minus 0 is 2. Class size is 2. Therefore, if we add 2, we get the midpoint. Okay, now for 3 if we add 2, we get 5. Again for 5 if we add 2, we get midpoint as 7. Again for 7 if we add 2, we get midpoint as 9. Again for 9 if we add 2, we get midpoint as 11. Okay, and again for 11 if we add 2, we get midpoint as 13. Okay, now what is the sum of the frequencies? So 1 plus 2 plus 1 plus 5 plus 6 plus 2 plus 3, I'll get 20. Okay, so this will be sigma fi. So also in the question only they have given. Okay, in 20 houses in a locality they have given. Therefore my sigma fi should be equal to 20. If this is not coming 20, somewhere in the calculation I have gone wrong. Okay, now let us calculate what is fi, xi fi. 1 into 1 is 1, 2 into 3 is 2 3 is 6, then 1 into 5 is 5, then 5 7 is 35, 6 into 9, 6 9 is 54, then 2 into 11 is 22, 3 into 13 is 39. Now if I add all this, I'll get sigma fi xi. So summation of this will be 162. Some calculation I am skipping, you should do by yourself. Now what is mean given by? Okay, mean is given by x bar is equal to sigma fi xi by sigma fi. So sigma fi xi is 162 divided by 20. So this you will get 8.1. So what it means, on an average there are 8.1 plants in each house out of the 20 houses in that locality. And here in the question they have also asked which method do you use to find the mean and why. So this is direct method, right? Direct method, because values of xi and fi are small. So both xi and fi, you can see they are either single digit or double digit. So that's why XIFI, calculating XIFI was not difficult, and also calculating sigma FI XI also was not difficult. So whenever the values of XI and FI are large, when they are more than 2 digits, then we can go for assumed mean method or by step division method. Exercise 13.1, question number 2. Consider the following distribution of daily wages of 50 workers of a factory. Find the mean daily wages of the workers of the factory by using an appropriate method. So this data I have reordered and written in this column wise fashion. Okay, so here you can see 12 workers are getting wages between 500 to 520, and 14 workers are getting wages between 520 to 540, and similarly 8 workers are getting wages from 540 to 560, and 6 workers are getting 560 to 580, and 10 workers are getting wages from rupees 580 to 600. I should find the mean. So to find the mean, I should first find xi. What is xi? Xi is the midpoint of the class interval. Okay, the first column is the class interval. So what is the midpoint of 500 and 520? So here if you add 500 plus 520 and divide by 2, you get how much? This is 1020 by 2. So you will get 510. Okay, so 510 is the mid value between 500 and 520. So what is the next mid value? Next also I can calculate in the same fashion, but what is the other method? And what is the class width? Class width is, okay, first class interval is 500 to 520, right? So 520 minus 500 is how much? 20. So 20 is the class width. So for first xi, if I add 20, it becomes 530. So 530 is the midpoint of the second class interval. So plus 20 if I add, it becomes 550. So 550 is the midpoint of the third class interval. So plus 20 is 570. Now again 590. 590 is the midpoint between 580 and 600. Now what is the value of XIFI? See, XIFI, you can see XI are all 3-digit numbers, and FI is 2-digit number. So if I multiply, I'll get huge values. So direct method means it is very tedious task. So I won't go for direct method. I'll see. First I'll find D. Okay, D is given by xi minus a. Now out of in xi column, the mid value is 550. So 550 I will take as a. Therefore 510 xi minus a. So 510 minus 550. 510 minus 550 is minus 40. I'll get minus 40. And 530 minus 550 is minus 20. I'll get. So 550 minus 550, 0. Then 570 minus 550 plus 20 I'll get. And 590 minus 550, I'll get plus 40. Now still here there are double digit number here. Now I'll make it further simpler. Instead of finding FI DI, I'll find UI FI. Before that I'll find what is UI. UI is equal to DI by H. Okay, what is H? H is equal to 20. Okay, H is equal to 20. Now di by 20. So that is di by 20. So what is minus 40 by 20? I'll get minus 2. So minus 20 by minus 20 by 20 minus 1. So 0 by 20 is 0, 20 by 20 is 1, 40 by 20 is 2. Now see, I got all single digit value here. Now UIFI is very easy to find. UIFI multiply frequency with U. So 12 twos are 24. So minus 24 I will get 14 into minus 1 minus 14. Now 8 into 0 is 0. Then 6 into 1 is 6. Then 10 into 2 is 20. Now if I add all this, how much I'll get? I'll get sigma ui fi is equal to, I'll get minus 12. Okay, I'm skipping calculation. You can find it by yourself. Now what is mean? So in step division method, what is the formula for mean? X bar is equal to a plus h into ui, right? So what is a? I have chosen as the mid value here, that is 550. So 550 plus what is h? H is the class width that is h is 20. What is ui? Ui is nothing but, sorry, u bar is sigma fi ui by sigma fi, right? So this is minus 12 by, so, and what is the sum of the frequencies? I have not calculated. So sum of the frequencies is 50. So is it given in the question? Okay, yeah, in the question also it is given, it is 50 workers. So actually if I add the frequencies, I should get 50. If I won't get 50, somewhere in the addition I have made mistake. Okay, so now here by 50. Now if you simplify this, you get 550 minus, so 20 into 12 by 50. So here actually you can simplify. So when we simplify, your calculation becomes easy. Now 20 into 10 by 5, 20 into 10 by 5, you will get 4.8. Okay, so plus into minus is minus. Now don't take LCM here. Okay, now 550 minus 4.8, it is 545.2. So this is the mean. So what it means, each worker is getting 445.2 rupees as salary on an average. So X bar is rupees 545.2. Exercise 13.1, question number 3. The following distribution shows the daily pocket allowance of children of a locality. The mean pocket allowance is rupees 18. Find the missing frequency F. So here you can see 7 children are getting pocket allowance between 11 to 13 rupees. 6 children are getting allowance between 13 to 15 and so on. Okay, but here frequency is missing. Okay, how many children are getting an allowance between 19 and 21 rupees? That's the question. So the same data I've arranged in columns, you can see. So here the first column will be the class interval, that is the daily pocket allowance in rupees, and the second column will be the number of children. Number of children will be the frequency, that is Fi. Okay, now the third column will be xi. So what is xi? Xi will be the midpoint of the class interval. Okay, that means, okay, what is the midpoint of midpoint between 11 and 13? So it is 11 plus 13. 11 plus 13 divided by 2, it is 4. 24 by 2. 24 by 2 is 12. So midpoint between 11 and 13 is 12. Okay, now what is the interval width, class interval width? That is 13 minus 11. 13 minus 11 is 2. So 2 is the class interval. So if I add to the first xi, so x1 is 12 I got. If I add 2 to x1, I'll get x2. That is 12 plus 2. 12 plus 2 is 14. So 14 is the midpoint in the second interval. Plus 2, 16. 16 is the interval in the third interval. Sorry, 16 is the midpoint in the third interval. Plus 2 is 18. So 18 is the midpoint in the fourth interval. Similarly, here it is 20. Here it is 22. Here it is 24. Now what is fi xi? This is the product of frequency and xi. So 7 into 12. 7 into 12 is 84. Okay, then 6 into 14 also is 84. Then 9 into 16 you get 114. 13 into 18 you get 234. Then so here 20 into f is 20f only, right? 20f only. Then here 5 into 22. 5 into 22 is 110. Then 4 into 24 is 96. Now if I add all this, what should I get? In the question they are told they have not given the total number of children, right? Okay, it's okay. So here if I add all the frequencies, I'll get 44 plus f. So this frequency is not known. This is f only. So the remaining values added together, it is 44. So 44 plus f I'll write. So this is nothing but sigma fi. Sigma fi is 44 plus f. And what is sigma fi xi? So sigma fi xi you will get 752 plus 20f. So calculation I am skipping, it is left to you. 750 plus 20f. Now what is the formula for mean in the indirect method? So mean is equal to sigma fi xi by sigma fi. So mean already they are given in the question only. The mean pocket allowance is 18 rupees 18. They have given in the question itself. Therefore 18 is equal to, what is sigma fi xi? It is 752 plus 20f. So divided by, what is sigma fi? It is 44 plus f. Now if we cross multiply, so this is 18 into 44 plus f is equal to 752 plus 20f will get. So 18 into 44 will get 792 plus 18 into f is 18f only, right? 18f, this is equal to 752 plus 20f. Bring all the f terms to the right hand side and the constant term to the left hand side. So 752 I'll bring to the left, 18f I'll bring to the right hand side. So 792 minus 752 is equal to 20f minus 18f. So 20f minus 18f is 2f. So here 792 minus 752 is 40. Therefore f is equal to 40 divided by 2. Okay, therefore f is equal to, what is 40 divided by 2? It is 20. Therefore f is equal to 20. Therefore what is the conclusion? 20 children's got pocket allowance between 19 and 21. And that completes this problem. Exercise 13.1, question number 4. 30 women were examined in a hospital by a doctor, and the number of heartbeats per minute were recorded and summarized as follows. Find the mean heartbeats per minute for this woman, choosing a suitable method. So here you can see heartbeat is given here and number of women here. So 2 women have heartbeat of 65 to 68. 8 women have heartbeat between 74 to 77, like this. Okay, same data I have arranged in column wise. So first column is number of heartbeats per minute, and the second column is number of women. So number of women I'll take as frequency. Now if I add all the frequency, I should get equal to 30. Okay, because they have told that 30 women were examined. So if we check it, 4 plus 2 plus 3 plus 8 plus 7 plus 4 plus 2 will be equal to 30. Okay, now class interval, you can see in the first class interval the lower limit is 65, the higher limit is 68. So 65 plus 68, if you divide by 2, if you add and divide by 2, you get 66.5. So the first midpoint is 66.5, that is xi. And what is the class width? So upper limit is 68 and lower limit is 65 from the first class interval. So if we subtract, it is 3. Class interval is 3, that is h. This is upper limit, this is lower limit. So now if I add this 3 to the midpoint of the first class interval, I'll get the midpoint of the second class interval. So 66.5 plus 3 is 69.5. So plus 5 again, if I do, I'll get 72.5. Then again I'll get 70.5, then 78.5, then 81.5, then 84.5. 84.5 is the midpoint of the last class interval. Now can I go for direct method? If I want to do direct method, I should do xi fi or fi xi, whatever you may say it. I should multiply f and x. So here xi has big values. So if I multiply, I'll get big value, then it will be very complicated. So I'll rule out doing this direct method. I'll go for step deviation method or for assumed mean method. So first I'll calculate d is equal to di is equal to xi minus a. So what is a now? So from the values of xi, the middle value is the third value. There are 7 values for xi. So sorry, fourth value is the middle value. Okay, 70, which is 75.5. So 61st value xi minus a, 66.5 minus 75.5, I'll get minus 9, and 69.5 minus 75.5, I'll get minus 6, and here I'll get minus 3. Here 75.5 minus 75.5 is 0. 78.5 minus 75.5 is 3. 81.5 minus 75.5, I'll get 6, and the last I'll get 9. Now I can go for assumed mean method, but seeing the values of di, I'll go for step deviation method, because all the values of di are divisible by 3, and 3 is also the class width. Okay, so I'll take u is equal to d by h is 3, ui is equal to di by h. Now minus 9 by 3 is minus 3, minus 6 by 3 is minus 2, minus 3 by 3 is minus 1. So here 0, so here 1, here 2, here 3 I'll get. Now I'll do fi ui, so that is product of frequency and ui. So 2 into minus 3 is minus 6, 4 into minus 2 is minus 8. Then 3 into minus 1 is minus 3. Then 8 into 0 is 0. Then 7 into 1 is 7. 4 2s are 8 here. Then 2 3s are 6. Now if I add all the values of the last column, I'll get sigma fi uy. Now minus 6 minus 8 minus 3 plus 7 plus 8 plus 6, I'll get 4. Please cross verify it. Now in the step deviation method, what's the mean given by? It is given by x bar is equal to a plus h into u bar, where u bar is given by sigma fi uy by sigma fi. So this is equal to what is a 75.5 we have taken here, plus h is the class width. Class width is 3. So you can verify that all the class have class width 3. Okay. Then into sigma fi uy is 4 divided by sigma fi is 30. So 3 1s are 3, 3 10s are 30. Now 75.5. So don't take LCM here. So now 4 by 10. 4 by 10 you get 0.4. So this is equal to 75.9. X bar is equal to 75.9 heartbeats per minute. Okay. Beats per minute. So that means on an average these 30 women have 75.9 heartbeats per minute. And that completes this problem. Exercise 13.1, question number 5. In a retail market, fruit vendors were selling mangoes kept in packing boxes, the boxes containing varying number of mangoes. The following was the distribution of mangoes according to the number of boxes. Find the mean number of mangoes kept in the packing box. Which method of finding the mean did you choose? Okay, here you can see there are 15 boxes which contain 50 to 52 mangoes. There are 110 mangoes which contains, there are 110 boxes which contain 53 to 55 mangoes, and so on. And similarly at the last you can see there are 25 boxes which contain 62 to 64 mangoes. But here in the class interval you can see the class interval are not continuous. 50 to 52, then here it is starting from 53 and it is ending at 55 and it is starting at 56. So the class interval is not continuous. So we should convert the class interval into continuous form. So to do that, what will I do is I will reduce the lower limit by 0.5 and increase the upper limit by 0.5. So after doing that, I'll get this new class interval. Okay, the first class interval will be 49.5 to 52.5. Second will be 52.5 to 55.5. Here you can see the upper limit of the first class interval is 52.5 and the lower limit of the second class interval is 52.5. This is what is called as continuous class interval. Here in the second class interval, the upper limit is 55.5. The lower limit of third class interval is 55.5. So class interval should be like this to make calculation. Okay, if it is not so we should convert as in this example. And the frequencies are 15, 110, 135, 115 and 25. Now I should calculate xi. So xi is the midpoint of the class interval. So in the first class interval, the lower limit is 49.5, the upper limit is 52.5. If I sum it, 10, 9, 10, 11, 9, 10, 11, 12, carry 1. So 102.0. Okay, so 102 if I divide by 2, I'll get as 51. Okay, so the first midpoint of the first class interval is 51. Now what is the class width? Okay, class width is upper limit minus lower limit. You can check this in any class interval. So in the first class interval, 52.5 is the upper limit, lower limit is 49.5. If I subtract 0, then 12 minus 9 is 3, so here it is 0. 3.0 means it is 3, so this is the class interval, that is H. Okay, now if I add 3 to the first midpoint, 51 plus 3 I'll get as 54, then 54 plus 3 I'll get as 57, and 57 plus 4 is, sorry, 3 is 60, then 60 plus 3 is 63. So 51, 54, 57, 60 and 63 are the corresponding midpoints of the given class interval. Now to find the mean, if I go for direct method, I should find Fi Xi. So here in Fi there are 3-digit numbers, and in Xi there are 2-digit numbers, so I should keep multiplying. I'll get very huge number, and it's a tedious job, and we are prone to make mistakes. So I won't go for direct method. I'll go for assumed mean method or by step division method. So in assumed mean method, what is the formula? X bar is equal to A plus D bar. Okay, and in the step deviation method, what is the formula for mean? X bar is equal to A plus H into U bar. So I can go for these two methods. So this direct method is ruled out because I'll get very big values. Now I'll find D. D is equal to Xi minus A. Now out of these 1, 2, 3, 4, 5 5 values of Xi is there. Out of this, the middle one is 57. Therefore A I will take as 57. A is equal to 57. Now Xi minus A. Okay, Xi minus A is Di. Now what is first? D1 is 51. 51 minus 57. 51 minus 57 is minus 6. Then 54 minus 57 is minus 3. Then 57 minus 57 is 0. Then 60 minus 57 is 3. Then 63 minus 57 is 6. Okay, now again I can further reduce these values by taking U is equal to Di by H. So what is H? Di by, what is H? H is 3. Okay, now if I divide the values in previous column by 3, I'll get values for this column, that is minus 6 by 3 is minus 2, minus 3 by 3 is minus 1, then 0 by 3 is 0 only, 3 divided by 3 is 1, 6 divided by 3 is 2. Now the last column I will make Ui Fi. So Ui Fi or Fi Ui is the product of frequency and U. Okay, now 15 into minus 2 is minus 30. 110 into minus 1 is minus 110. 135 into 0 is 0. 115 into 1 is 115. And the last 25 into 2 is 50. Now if I add all these values in the last column, what will I get? I'll get sigma Fi Ui. So here sum of all these values will be equal to 25. This step I am skipping, you can verify it. Now what is the sum of the frequencies? Oh, this I have not calculated at all. So sigma into Fi. So here the sum of all the frequencies, I'll get 400. So please verify that. Now what is X bar? That is the mean. I'm going for step deviation method, right? So here, so now mean is equal to A plus HU, A plus HU bar. So what is A? A I had taken as 57. So 57 plus what is H? The class width is 3 and U bar is sigma Fi Ui by sigma Fi. So this is equal to 57 plus 3. Sigma Fi Ui is 25 by sigma Fi is 400. Okay. So here we can simplify. 4 4 3 is 12. 4 4 4 is 16. 25 1 is 25. 25 16s are 400. Okay. Now I am left with 57 plus 3 by 16. So this is 57 plus 3 by 16. 3 by 16 you will get 0.1875. Please cross verify. So this plus this is 57.1875, or approximately this is equal to 57.19. This is the mean. So what does it mean? Each mango box contains 57.19 mangoes. Exercise 13.1, question number 6. The table below shows the daily expenditure on food of 25 households in a locality. Find the mean daily expenditure on food by a suitable method. So here you can see 4 houses as expenditure of 100 to 150 rupees, and 5 houses has an expenditure of 150 to 200 rupees. Similarly, here you can see 2 houses has an expenditure of 300 to 350 rupees. So total number of houses is 25. So all this data I have arranged in columns like this. So number of households I'll take as frequency, and daily expenditure will be the class interval. Now I should find xi. So what is xi? Xi is the midpoint of the class interval. So what is the class interval here? What is the first class interval? It is 100 to 150. So what is the midpoint? 100 plus 150 by 2. This is 250 by 2. 250 by 2 is 125. Okay. So 125 is the first midpoint of the first class interval. Now what is the class width? Class width is in the first class interval, higher limit is 150, lower limit is 100. So if we subtract, we will get 50. So 50 is the class interval, that is h. So if I add 50 to 150, how much I will get? 175. So 175 is the midpoint of the second class interval, plus 50, it is 225. 225 is the midpoint of the third class interval, plus 50 is 275. 275 is the midpoint of the fourth class interval, plus 50 gives 325. 325 is the midpoint of the last class interval. Now can I go for first method, fi xi? So you can see xi, the values of xi are in 3 digits. So if I multiply frequency with xi, I'll get huge numbers, and also addition of that fi xi also will become tedious task. So I won't go for direct method, I'll go for next method. What is that? In assumed mean method, what is the formula for mean? It is x bar is equal to a plus d bar. In the second step deviation method, x bar is equal to a plus h into u bar. Okay, we can go for assumed mean method or by step deviation methods. Let us see which will work out. So I'll find d. What is, so di is x minus a, xi minus a, right, xi minus a. So what is a? So out of this 1 2 3 4 5, middle value is 225. Okay, now 125 minus 225 is minus 100. Now here I'll get minus 50. Then 225 minus 225 is 0. Then 275 minus 225 is 50. Then here I'll get 100 plus 100. Okay, now what is u? U is equal to d by h. Ui is equal to di by h. That means in the previous column whatever values is there, I should divide by h. H is how much? H is 50 I got. So minus 100 by 50 is minus 2. So here also I can't go for assumed mean method, because in di, you can see in di there are some values, there are some 3-digit values, 100 is there. So again multiplying frequency by di. So if I multiply frequency by d, I'll get huge values. Okay, that's why I'll go for step division method. To find step division method, I should find u and fi ui I should find. So here first one, u1 is minus 100 by 50 is minus 2. In the second case, minus 50 by 50 is minus 1. So here 0 by 50 is 0, and 50 by 50 is 1, and 100 by 50 is 2. So now ui fi I will find, or fi ui, whatever you may call it. So here now 4 into minus 2 is minus 8, 5 into minus 1 is minus 5, then 12 into 0 is 0, 2 into 1 is 2, then again this last 2 into 2 is 4. Now if I add the last column, what will I get? I'll get sigma fi ui. So when I calculate, I'll get minus 7. Please cross verify. Now here also I have not found what is the sum of frequency. In the question only they have given it's 25 household. Okay, so if I add all the frequency, I should get 25. So sigma fi, so 4 plus 5 9, 9 plus 12, so 9 plus 12 is 21, 22 23 24 25. Oh yes, I'm getting. Okay, sigma fi is 25. Now I'm going for step division method. Therefore x bar is equal to a plus h into u, right? So substitute. So a, so what is a is 225, plus what is h? This class width is 50, plus u bar. So what is u bar? U bar is sigma fi ui by sigma fi. So sigma fi ui is minus 7. So and sigma fi is 25. So here 25 ones are 25 twos are. So here I'll get 225 minus 2 sevens are 14. So 225 minus 14 is 211. So mean is 211, or x bar is rupees 211. So that means 211 rupees is the average money that these 25 households are spending. Exercise 13.1, question number 7. To find out the concentration of SO2 in the air in parts per million, that is ppm, the data was collected for 30 localities in a certain city and is presented below. So parts per million means if you take 1 million parts, okay, take for example the third class interval. So here if you take 1 million parts of air, out of that 0.08 to 0.12 parts will be SO2. Similarly, if you consider the last class interval, if you take 1 million parts, out of that 0.2 to 0.24 parts will be SO2. Okay, we should find the mean concentration of SO2 in the air. Okay, same data I have written here. So frequency is given. So they have told it's 30 localities. Now if I sum up the frequencies, it should be equal to 30. So let us check it. So sigma Fi. So 9 plus 9, 18, 19, 20, 21, 22, 22, 22 plus 8. So I am getting 30. Okay, correct. Now I should find xi. So what is xi? Xi is the midpoint of the class interval. Considering the first class interval, lower limit is 0.00, upper limit is 0.04. If I add it, I'll get 0.04. Now if I divide by 2, I'll get 0.02. So 0.02 is the midpoint of the first class interval, 0.02. Now what is the class width of the interval? So 0.04 is the upper limit of the first class interval, and lower limit is 0.00. So if I subtract, I will get 0.04. Okay, so 0.04 is the class width. Class width is nothing but equal to h, denoted by h. Now if I add h to the midpoint, I'll get the next midpoint. So if I add 0.04 to 0.02 here, I'll get 0.06. So 0.06 is the midpoint of the second class interval. So 0.06 plus 0.04, again if I add, I'll get 0.10. This is the midpoint of the third class interval. Similarly, midpoint of fourth class interval will be 0.14, and the fifth midpoint will be 0.18. Then again if I add again 0.04, I'll get 0.22. Now what is Fi into Xi? So that is frequency into Xi. 4 into 0.02, 4 2s are 8, so 0.08. Then 9 into 0.06, 9 6s are 54, so 0.54. 9 1s are 9, so this is 0.90. So 2 14s are 28, so this is 0.28. 4 into 18, 4 into 18, 4 2s are 4 8s are 32, 4 1s are 4, 5 6 7, and 2 into 22 is 0.44. Now if I sum up all these things, I'll get sigma Fi Xi. So this I'll get as 2.96. You can cross verify. Now what is the mean? Mean is given by sigma Fi Xi by sigma Fi. So this is equal to 2.96 divided by 3.0. Sorry, this divided by 30. Okay, divided by 30. So this is equal to 0.0986. I'll get. Okay, it is recurring. Now I can approximate this to 6. I can cut and add 1 here, so it becomes 0.099 parts per million. So on an average, if you take 1 million parts of air, out of that 0.099 parts will be SO2. Exercise 13.1, question number 8. The class teacher has the following absentee record of 40 students of a class for the whole term. Find the mean number of days a student was absent. So here in the chart you can see 11 students are absent for 0 to 6 days, and like this you can see here only one student is absent for 38 to 40 days. Okay, this data I have written in columns like this. Now you can check that if I add the number of students, it will be equal to 40. I've got it here. Okay, so the number of students I'll take as frequency, that is F. And now I'll calculate xi. So xi is nothing but the midpoint of the class interval. Now considering the first class interval, so in the first class interval is 0 to 6. So upper limit is 0, lower limit is 6. If I add, I'll get 6, and if I divide by 2, I'll get 3. So 3 is the midpoint of the first class interval. Okay, now what should I do? I should calculate the next midpoint, right? So what is the class width? So upper class width of first class interval is 6 and lower class interval is 0. Sorry, upper limit is 6 and lower limit is 0. So if I subtract, I'll get 6. So 6 is the h, class width of the class interval. But here I can't consider this class width, because you can see class width is changing. In the first class interval, class width is 4, and in the 1 2 3, in the fourth class interval, you can see class width is 6, and in the fifth class interval, you can see class width is 8. So class width is changing. So now I should calculating midpoint is a little tough, because in every class interval I should check it. Okay, so now what is the midpoint of 6 and 10? So it is 6 plus 10 is 16. 16 by 2 is 8. So what is the midpoint of 10 and between 10 to 14? So 10 plus 14 is 28. 28 divided by 2 is, sorry, 24 divided by 2 is 12. So 12 is the midpoint. So now what is the midpoint of 14 and 20? So when I add 14 and 20, I'll get 34. 34 divided by 2 is 17. Okay, so here midpoint of between 20 and 28, so it is 48. 48 divided by 2 is 24. So midpoint of 28 and 38, here I'll get 33, and the last one, midpoint of 38 and 40 is 39. I'll get. So here, if the class interval is class width is same in all the class interval, then calculating midpoint is very easy. If we add the class width to the previous midpoint, we'll get the next midpoint. But here class width is changing. That's why for every class interval we should separately calculate the midpoint. Now what is Fi into Xi? So this is the product of frequency and Xi. So 11 into 33 is 33. 10 into 80, 10 8 are 80. Then 7 into 12 is 84. 14 into 17 is 68. 4 into 24, you get 96. 3 into 33, you get 99. 1 into 39, you get 39. So if I sum up all this, I'll get sigma Fi Xi. So this I'll get 496 I'll get. Okay, so calculation I'm skipping, just cross verify. Now what is mean? Mean is given by sigma Fi Xi by sigma Fi. So here 496 by 40, I'll get 12.475. Okay, now I can approximate this to 12.48 days. So on an average, each student was absent for 12.48 days. Exercise 13.1, question number 9. The following table gives the literacy rate of 35 cities. Find the mean literacy rate. So here you can see in 3 cities the literacy rate is 45 to 55%, and 10 cities have literacy rate 55 to 65, and so on. The last 3 cities has literacy rate of 85 to 95%. Now same data I have written here in column wise. Now the number of cities I'll take as frequency F. Now if I add all the frequencies, how much should I get? Sigma Fi. Okay, I should get 35. So 10, 20, 28, 29, 29 plus 6, 35. Okay, 35 I am getting. Now I should find xi. Xi is the midpoint of the class interval. So here all the class interval have the same width. Okay, so now midpoint of 45 and 50, midpoint between 45 and 55 is, so 45 plus 55 is equal to 100. So 100 divided by 2 is 50. So midpoint of the first class interval is 50. So what is the class width? Class width is 55 by 45. So it is 10. 10 is the class width, that is h. So this is the upper limit of the first class interval, this is the lower limit of the first class interval. So if I subtract, I'll get the class interval. Okay, and class interval or class width is same for all the intervals, you can see. Now 50 plus class interval, that is 50 plus h is 60. Okay, 60 is the midpoint of the second class interval. 60 plus 10 is 70. 70 is the midpoint of the third class interval. 70 plus 10 is 80. 80 is the midpoint of the fourth class interval. And 80 plus 10, 90. 90 is the midpoint of the last class interval. Now, can I go for direct method? If I go for direct method, I should find Fi xi. So Fi and xi, I'll be getting big numbers. So I'll avoid going to direct method. I'll go for step deviation method or assumed mean method. In assumed mean method, what is mean given by? Mean is given by a plus d bar. So and in step deviation method, mean is given by a plus h into u bar. Okay, and now I'll avoid. I can do direct method also. So since I'll get big numbers, I won't go for it. Now I'll find d. Di is equal to xi minus a. Okay, xi minus a. Now what is the middle term in xi? So there are five numbers, and 70 is the middle of this xi. Okay, so 70 I'll take as a. So 50 minus 70, 50 minus 70 is minus 20. 60 minus 70 is minus 10. 70 minus 70 is 0. 80 minus 70 is 10. 90 minus 70 is 20. Now we can see all these numbers in this column, in the last column, is divisible by 10. So 10 is also the class interval. So I'll take uy is equal to d by h. So where h is equal to 10. Okay, so d by h, d by 10. So 20 minus 20 by 10 is minus 2. Minus 10 by 10 is minus 1. 0 by 10 is 0. 10 by 10 is 1. 20 by 20 by 10 is 2. So now I'll calculate Fi ui. So that is the product of frequency and ui. So 3 into minus 2. 3 into minus 2 is minus 6. Then 10 into minus 1 is minus 10. Then 11 into 0 is 0. Then 8 into 1 is 8. Then 3 into 2 is 6. Now if I sum up all the values in the last column, I'll get sigma Fi ui. So here I'll get minus 6 minus 10 plus 8 plus 6, I'll get minus 2. Please cross verify. Now going by step deviation method, x is equal to a plus hu bar. So what is a? A is 70 I have taken, okay, the mid value of xi. So 70 plus h is 10 into ui. What is ui given by? Ui is given by sigma fi ui by sigma fi. So 70 plus 10 into minus 2 by 35. So here 5 2s are 10, 5 7s are 35. So here I'll get 70. So here minus into minus. So minus 4 by 7. So here I'll get 70 minus. So 4 by 7 is 0.571 I'll get. So I'll get 70 minus 0.571 is I'll get 69.428. So you can approximate here, cancel this 8, add 1 here. So approximately it is 69.43. So that means out of these 35 cities, the average literacy rate is 69.43%. 43%, okay. The next topic in this chapter is mode of group data. Until now we did several problems related to mean of group data. In the last problem itself, we saw that the literacy rate of 35 cities were given, okay, and we found the mean. It came around 69.43. That means among this 35 cities, the average literacy rate is 69.43. Here you can make one observation, that this class interval 65 to 75, this class interval has got the highest frequency. 11 is the highest frequency among all this, okay. So what if I find the mean of only this class interval? If I find the mean of only this class interval, then it is called as mode of this group data. In the textbook you can see the formula for mode of group data. It is given by mode is equal to L plus F1 minus F0 divided by 2F1 minus F0 minus F2 into H, where L is the lower limit of the model class. So applying this formula to this problem, what is the model class? Model class is the class where the frequency is the highest. Therefore 67 to 75, this is the model class, because 11 is highest among all these frequencies here. So now what is L? The lower limit of the model class. Therefore L is 65, and F1 is the frequency of the model class, so that is 11, and F0 is the frequency of the class preceding the model class. So if this is the model class, the class preceding the model class is this one, and the frequency of this class is 10, and F0 is the frequency of the class succeeding the model class, that is 8. So this is the model class. Therefore the class succeeding the model class is this, and the frequency is 8. So if we substitute all these values, we get the mode of this group data. In the textbook there is one example problem. A survey conducted on 20 households in a locality by a group of students resulted in the following frequency table for the number of family members in a household. Family size, and this is the number of families. Find the mode of this data. So what it means, there are 7 families where there are 1 to 3 members. There are 8 families where there are 3 to 5 members. Going on like this, there is only one family where there are 9 to 11 members. I should find the mode. So before finding the mode, first step I should do is I should find the model class. So among all the frequencies here, so I'll take a number of families as frequencies. So among all these frequencies, the highest frequency is 8. So 3 to 5, this is the model class. This class is model class. So going by this formula, what is L? L is the lower limit of the model class. So lower limit means it is 3, and H is the size of the class interval. So here all the class interval is same, and all the class size is same, and class size is 5 minus 3 or 3 minus 1 here. So it is 2. The class size is 2, and frequency f1 is the frequency of the model class, that is 8. f0 is the frequency of the class preceding the model class, that is 7. f2, this is the frequency of the class succeeding the model class, that is 2. So after substituting all this in the given formula, we get mode to be equal to 3.286. So what it means? It means this class has got average of 3.286. okay, so it means 8 families have got an average of 3.286 family members. If I find the mean, what will I get? If I find the mean, I'll get the average of this full data. Okay, so mode is only the average of this data, mean is average of full data. Okay, I hope you got the idea of mode. All these example problems are very simple. They have explained in a very simple language. Just go through it. As I told you, mode is the average in the highest frequency class interval of the group data, whereas mean is the average of the full grouped data. And to find the mean, there are 3 formulae. Whichever formula is convenient, we can choose that formula and we can do it. We have already done several problems using these 3 formulae. And to find the mode, this is the formula. Mode is equal to L plus f1 minus f0 by 2 f1 minus f0 minus f2 into h. Exercise 13.2, question number 1. The following table shows the ages of the patient admitted in a hospital during a year. Find the mode and mean of the data. Compare and interpret the 2 measures of central tendency. So here in the first row they are given age in years, second row they are given number of patients. So there are 6 patients whose age is between 5 to 15. There are 11 patients whose age is between 15 to 25, and so on. There are 5 patients whose age is between 55 to 65. So the first row I can take as class interval, second row I can take as frequency, and I have plotted here. I have written the same data here. Okay, now if I add the frequencies, what will I get? I'll get sigma f5. So the sum of 6 plus 11 plus 21 plus 23 plus 14 plus 5 is 20, and now I'll find xi. What is xi? Xi is the mid value of the class interval. Okay, so what is the mid value of between 5 and 15? So it is, add the 2 limits, 5 plus 15 by 2 gives 20 by 2, which is equal to 10. So 10 is the mid value of the class interval 5, 15. Okay, 5 and 15. And what is the next mid value? So before that we can observe that the class size is same, class width is same. So what is the class width? So 15 minus 5 is 10. This is the upper limit of the first class interval. This is the lower limit of the second class interval. 15 minus 5 is 10. So class size or class width is 10. Now if I add 10 to the first mid value, I'll get 20. So 20 is the midpoint of the second class interval. So plus 10 gives 30. 30 is the midpoint of the third class interval. Similarly 40, 50 and 60, these are the midpoints of these corresponding class intervals. Now what is the formula for mean? mean is given by x is equal to sigma fi xi by sigma fi. Now can I go and find fi xi? So if I do that, I'll get very big values, because frequency, the second column and the third column have all two digit numbers. So multiplying those things will be a tedious task. So I won't go for a direct method. I'll go for assumed mean method or by step division method. Okay, to do that I should find d. What is d? D is equal to xi minus a. Now what is d1? So before that I should get the middle value. So among these values of xi, so 1 2 3 4 5 6 values are there in xi. I will take third value. So third and fourth, these two are the middle value of xi. I'll take 30 as a. Okay, I'll take 30 as a. So now what is d1? d1 is x1 minus a. So that is x1 is 10. So 10 minus 30, I'll get minus 20. So next d2, that is x2 minus a. I'll get 20 minus 30 is minus 10. So here 30 minus 30 is 0. Here 40 minus 30 is 10 I'll get. Here 50 minus 10 is, sorry, 50 minus 30 is 20. And here 60 minus 30 is 30. Okay. Now all this data in the last column are divisible by 10. 10 is also the class size or the class width. Okay. Now next I'll take ui is equal to di by h. Okay. Now divide the previous column by 10, all the elements of previous column by 10. So minus 20 by 10 is minus 2. Then here I'll get minus 1, here 0, 10 by 10 is 1, 20 by 10 is 2, 30 by 10 is 3. Now I'll calculate fi ui. So this is product of frequency and ui. So 6 2s are 12. So minus sign is there. 11 into minus 1 minus 11. 21 into 0 is 0. 23 into 1 is 23. Now 14 into 2 is 28. 5 into 3 is 15. Now if I add all these values, I'll get sigma fi xi, which is equal to, sorry, it is sigma fi ui. Okay, sigma fi ui. So this is equal to 43. If I add all this, I'll get 43. Just cross verify. I'm skipping some calculation steps. Now I can go for step division method. This direct method I'll rule out. And mean is given by x bar is equal to a plus h into u bar. So what is u bar? U bar is equal to sigma fi ui by sigma fi. So here what is a? A I have taken as 30 plus what is h? H is the class width or the class size, that is 10 into, so this is sigma fi ui by sigma fi. So 43 by 80. 80 is the sum of the frequencies. Now 0 will get cancelled. Now this I'll get 30 plus, so 43 divided by 8, you can check it out, you will get 5.375. Okay, so I'll get mean is equal to 35.375. Okay, now I should find the mode. So to find the mode, what is the modal class? So which is the highest frequency? 23 is the highest frequency. Okay, so highest frequency is equal to 23. Therefore modal class is 3545. So you can avoid writing this sentence. Okay, just for your understanding I am writing. Therefore mode is given by L plus F1 minus F0 by 2F1 minus F0 minus F2 into H. Now substitute all the values. So here you get what is L? L is 35. L is the lower limit of the modal class. So modal class is 3545. So lower limit of modal class is 35 plus frequency of the modal class is 23 minus frequency of the class preceding the modal class is 21. So 21. Okay, then divided by 2 into F1, 2 into 23 minus F0 is again 21 and minus F2. This is the frequency succeeding the modal class, that is 14. You can see here. So 14 into 10. So 10 is the class width. Okay, now this is equal to 35 plus 23 minus 21 is 2. So here the denominator 2 into 23 minus 21 minus 14, you will get 11. Okay, into 10. So don't take LCM here. So this you will get 35 plus 2 into 10 divided by 11, you will get 1.8181. So the final answer is 35 plus 1.8181 is 36.8181. Okay. So in this problem they have asked to compare and interpret the two measures of the central tendency. So mean we got as 35.375. So that means among all these 80 number of patients in the hospital, the average age is 35.375 and we got mode as 36.81. Okay, that means maximum patients with age 36.81 are getting admitted in the hospital. Okay, this one I have written, and that completes this problem. Exercise 13.2, question number 2. The following data gives the information on the observed lifetime in hours of 225 electrical components. Determine the modal lifetime of the components. So there are 225 components, and out of this 10 components have life hour of 0 to 20 hours, and there are 35 components whose lifetime is 20 to 40 hours. Going on like this, there are 29 components whose life is between 100 to 120 hours. And here you can see the highest frequency is 61. Okay, so there are 61 components whose lifetime is 60 to 80 hours. Okay, therefore highest frequency is 61. Therefore the modal class will be equal to 60 to 80. Okay, now I'll take the formula for mode is L plus F1 minus F0 by 2 F1 minus F0 minus F2 into h. So here you can see the class width, the class size is given by 20 minus 0 is 20. So this is the upper limit, this is the lower limit of the first class. Class size is 20, and class size is same in all the class. You can observe, okay, in the second, third, fourth, everywhere the class size is same, 20. Okay, now substitute all the data. What is L? L is the lower limit of the model class. So since 61 is the highest frequency, model class is 60 to 68. So 60 is the L plus F1 frequency of the model class, that is 61, minus F0 is the frequency of the class preceding the model class, that is 52 here. So 52 divided by 2 into F1. F1 we already know it is 61, minus F0 also we know it is 52, then minus F2. F2 is the frequency of the class succeeding the model class, that is 38 here, minus 38 into, so what is the class width or the class size? It is 20. Okay, now this is equal to 60 plus, so here 61 minus 52, you get 9. Okay, here 2 into 61 minus 52 minus 38, you get 32. Okay, I am skipping some steps. So this is 20 as it is. Now we can simplify. 2 10s are 20, 2 16s are 32. So 9 into, this is 60 plus 9 10s are 90 by 16. So you will get 60 plus 90 by 16 is 5.625. So ultimately you will get 65.625. So these many hours. So 61, what it means, 61 components here. 61 components have a lifetime of 65.625 hours. Exercise 13.2, question number 3. The following data gives the distribution of total monthly household expenditure of 200 families of a village. Find the model monthly expenditure of the families. Also find the mean monthly expenditure. So here you can see 24 families spend 1000 to 1500, 40 families spend 1500 to 2000. Similarly, here 7 families spend 4500 to 5000. I should find the mean and mode of this given data. So here if I'll take a number of families as frequency. Okay, now if I add all the frequency, I should get sigma fi, I should get this equal to 200. So in the question only they are given, okay, monthly expenditure of 200 families. So sum of all the frequencies should be equal to 200. If it is not there, our calculation is wrong or the given data itself is wrong. Now I should find xi. What is xi? Xi is the mid value of the class interval. So in the first class interval is 1500 to 1000 to 1500. So midpoint of first class interval will be 1000 plus 1500 by divided by 2. So this I will get as 1250. So 1250 is the mid value of first class interval. Now what is the class width or the class size? So if I subtract the lower limit from the upper limit, I'll get the class size. So I'll get 500. So 1500 is the upper limit and 1000 is the lower limit of the first class, and difference is 500, which is h. H is the class width or the class size. Now if I add 500 to the midpoint of the first class interval, so 1250 plus 500 is 1750. So 1750 is the midpoint of the second class interval. plus 500 I'll get 2250 plus 500 I'll get 2750 plus 500 I'll get 3250 plus 500 I'll get 3750 plus 500 I'll get 4250 plus 500 I'll get 4750. 4750 is the midpoint, mid value of the last class interval. Now I should find the mean. So to find the mean, if I go for direct method, I should find fi xi. So xi are all 4-digit number. So if I multiply frequency with xi, I'll get huge values. So I won't go for direct method. I can go for assumed mean method or step deviation method. For step deviation method or assumed mean method, first I should find di. So di is equal to xi minus a. So among all these values of x, what are the mid values? So there are 8 data. So 8 numbers are there. So 1, 2, 3, 4, fourth and fifth values are the middle values. Out of these two, I can take any one as assumed mean, that is a. So I'll consider fourth value as assumed mean, that is a. Now d1 is x1 minus a. So 1250 minus 2750 is minus 1500. Similarly 1750 minus 2750 is minus 1000. Similarly 2250 minus 2750 is minus 500. So 2750 minus 2750 is 0. 3250 minus 2750 is 500. So similarly I'll get here 1000, 1500. Now 4750 minus 2750 is 2000. Now if I want to find mean in assumed mean method, I should find fi di. So di here are again 3-digit and 4-digit numbers. Again I don't want to mess up finding fi di. I'll get huge values. Instead I'll find ui. Ui is equal to di by h. So what is h? H is 500. So 1500 minus 500 is minus 3. So 1000 minus 1000 by 5 minus 1000 by 500 is minus 2. Minus 500 by 500 is minus 1. So 0 by 500 is 0. 500 by 500 is 1. Here 2, here 3, here 4 I'll get. 2000 by 500 is 4. Now I'll find ui fi ui or ui fi, whatever you may call it. So multiply frequency with ui. So 24 into 3 is minus 72. 40 into minus 2 is minus 80. Then here it is minus 33, 0. Then 30 into 1 is 30. 22 into 2 is 44. 16 into 3 is 48. Then 7 4s are 28. Okay. Now if I add all the values of the last column, I'll get sigma fi ui. So this I'll get as minus 35. I'll skip this step. You can cross verify and check it. Now what is the mean given by? Mean is given by x bar is equal to a plus h into u bar. What is u bar? U bar is equal to sigma fi ui by sigma fi. So substitute a. What is a? Is 2750. 2750 I got here 2750. So 2750 plus h is 500. 500 u bar is sigma fi ui by sigma fi. Sigma fi ui is minus 35 divided by sigma fi is 200. Okay, 200. So here 2 zeros will get cancelled. So I am left with 2750 plus. So here plus into minus, minus I'll get minus. Here don't take LCM. 5 into 35 by 2 I'll get 87.5. So mean I'll get as 2662.5. So what it means, out of these 200 families, they are spending 266 to 2662.5 rupees on an average. Okay, x4 is equal to rupees 2662.5. Now I should find mode. So mode is given by L plus f1 minus f0 by 2 into f1 minus f0 minus f2 into h. So L. So what is the modal class? So which is the highest frequency here? 38. Sorry, it's the 40. Okay, modal class is, highest frequency is 40. Okay, therefore modal class is 1500 to 2000, that is the modal class. So now what is L? L is the lower limit of the modal class, that is 1500. Okay, 1500 is the lower limit of the modal class. So 1500 plus f1, frequency of the modal class, which is also the highest frequency among all the frequencies, minus f0 is the frequency of the class before the modal class, that is 24, minus 24 divided by 2 into f1, we know it is 40, minus f0 is 24, minus f2 is the frequency of the class succeeding the modal class, that is 33 here. Okay, minus 33 into what is h is 500. Okay, now this is equal to 1500 plus, so 40 minus 24 is 16. So here 2 into 40 minus 24 minus 33, you will get 23. So into 500. So don't take LCM. 1500 plus 16 into 500 by 23. So you will get 342.82. So 1500 plus 342.82 is 1847.82 or rupees 1847.82. So the modal class is second class. Okay, 1500 to 2000, that's the modal class. So their frequency is 40. So those 40 families are spending 1847.82. okay, on an average. Exercise 13.2, question number 4. The following distribution gives the state-wise teacher-students ratio in the higher secondary school of India. Find the mode and mean of this data. Interpret the two measures. So in the first column, number of students per teacher is there. In the second column, number of states or union territory is there. So you can see in 3 states, the number of students per teacher is 15 to 20, and in 8 states the number of students per teacher is 20 to 25, so on, and in the last one you can see in 2 states the number of students per teacher is 50 to 55. Now the second column I'll take as frequency, and if I add all this I'll get sigma fi. So sigma fi gives 35. Okay, and now to find the mean I should find xi. Xi is the midpoint of the class interval. So first class interval is 15 to 20. So class interval will be 15 plus 20. Sorry, midpoint will be 15 plus 20 divided by 2. So this is 32 20 35 by 2, so it gives 17.5. okay, 17.5. So what is the class width or the class size? So upper limit minus lower limit, so upper limit and lower limit of the first class gives 5. 5 as the mid, as the class width or the class size, that is h. okay, now we can see the class size in all the class interval is same only. okay, now for the first midpoint, if I add h, what will I get? 17 plus 5, 17.5 plus 5, I'll get 22.5, which is the midpoint of the second class interval, plus 5, 27.5, plus 5, I'll get 32.5, plus 5, I'll get 37.5, plus 5, I'll get 42.5, plus 5, I'll get 47.5, plus 5, I'll get 52.5. 52.5 is the midpoint of the last class interval. Now I should find mean. Can I go for Fi Xi? So Xi are all decimal, have numbers with decimal values. okay, so multiplying frequency with Xi, I'll get complicated numbers with decimal points. So I'll avoid doing Fi Xi. I'll find the mean using assumed mean method or by step deviation method. So I'll find di is equal to xi minus a. So how many values are there in xi? 1 2 3 4 5 6 7 8. There are 8 values. So middle values are 4th and 5th. These are the middle values. So I'll take 4th value as the assumed mean. So that means 32.5 I'll consider as a. Now di is equal to xi minus a. So d1 is equal to x1 minus 32.5. So 17.5 minus 32.5, I'll get minus 15. Then 22.5 minus 32.5, I'll get minus 10. 27.5 minus 32.5, I'll get minus 5. So here 32.5 minus 32.5 is 0. So here I'll get 5, here I'll get 10. Then 47.5 minus 32.5, I'll get 15. Then 52.5 minus 32.5, I'll get 20 here. Now further I can find ui. Ui is equal to di by h. What is h? H is equal to 5. We found it. So divide the 1 2 3 4th column by 5. So minus 15 by 5 is minus 3. Minus 10 by 5 is minus 2. So minus 5 by 5 is minus 1. So here 0. 5 by 5 is 1. 10 by 5 is 2. 15 by 5 is 3. 20 by 5 is 4. Now I can find Fi ui. So it's easy now. F is frequency, U is di by h, which we found already. So 3 into minus 3 is minus 9. 8 into minus 2, minus 16. 9 into minus 1, minus 9. 10 into 0, 0. 3 into 1 is 3. 0 into 2 is 0. 0 into 3 is 0. 2 into 4 is 8. And if I add all the values of the last column, I'll get sigma Fi ui. So this I'll get as 23. I'm skipping some steps. You can calculate and verify. Now what is mean given by? In step deviation method, mean is given by x bar is equal to a plus h into u bar. So what is u bar? U bar is sigma Fi ui by sigma Fi. So this is equal to a I have taken as 32.5 plus h is 5. So u bar is sigma Fi ui by sigma Fi. Sigma Fi ui is minus 23 by sigma Fi is 35. So 5 ones are 5, 5 sevens are 35. So here So I'll get 32.5. Here don't take LCM. So plus into minus is minus. 27 divided by 3. I'll get 3.28. So 32.5 minus 3.28. I'll get 29.21. So this is x bar. So on an average, these 35 states have 29.21 students per teacher. So now I should find the mode. So highest frequency is equal to 10, you can see. Okay, therefore what is the model class? Model class is 35. Okay, you can avoid writing this sentence. Just for your understanding I am writing. Okay, now mode is given by mode is equal to L plus F1 minus F0 divided by 2F1 minus F0 minus F2 into H. Okay, so this is equal to L is the lower limit of the model class. Model class is this one, 35. So 30 is the lower limit, plus F1 is the frequency of the model class, that is 10, minus F0 is the frequency of the class preceding model class, that is 9. Okay, this is that frequency 9, divided by 2 into F1 is 10 minus F0 is 9 minus F2 is the frequency of the class succeeding the model class, that is 3, minus 3 into H is the class width is 5. So here you will get 30 plus, so 10 minus 9 is 1. Okay, and 20 into 10 minus 9 minus 3, you will get 8. Okay, into 5. So ultimately don't take LCM here. So 30 plus 5 divided by 8, you get as 0.625, 0.625. So I'll get as 30.625. So this is the mode. You can see in the question they have asked to interpret. Okay, find the mode and mean of this data, interpret the two measures. So mean I got as 29.21. So overall out of these 35 states, the average student to teacher ratio is 29.21. Okay, and mean I got as 30.625. that means most states have got teacher to student to teacher ratio as 30.625. Exercise 13.2, question number 5. The given distribution shows the number of runs scored by some top batsmen of the world in one day international cricket match. So in the first column there is runs scored, in the second column there is number of batsmen. So here you can see 4 batsmen have scored 3000 to 4000 runs, and 18 batsmen have scored runs between 4000 to 5000 runs, and so on. And the last in the last row you can see 1 batsman has scored runs between 10,000 to 11,000. Find the mode of the data. So here I'll take the number of batsmen as F frequency. Okay, now here you can see the highest frequency. Okay, highest frequency is 18. Therefore modal class will be this one, 4000 to 5000. Okay, I'll write here. This is not necessary, just for your reference I'm writing. Highest frequency is 18. Therefore modal class is 4000 to 5000. So you can skip writing this and directly start from this step, mode. The formula for mode is given by L plus F1 minus F0 divided by 2F1 minus F0 minus F2 into H. Now what is L? L is the lower limit of the modal class. So modal class is 4000 to 5000. So lower limit is 4000. So 4000 plus F1 is the frequency of the modal class, that is 18. Okay, 18. So 18 minus F0 is the frequency of the modal class before the frequency of the class before the modal class, that is 4. In this case it is 4 divided by 2 into F1 is 18 minus F0 is 4 minus F2. F2 is the frequency of the class succeeding the modal class, that is 9 here. So 9 into H. What is H? H is the class width or the class size. We have not calculated the class size yet. Okay, in the first class the upper limit is 4000, the lower limit is 3000. So it is, when we subtract, it is 1000. So 1000 is the class limit. So we can observe that the class limit is the class size is constant in all the class, that is 1000. So this is equal to 4000 plus 18 minus 4 is 14. 14 divided by, so 2 into 18 minus 4 minus 9, if you calculate you will get 23. So into 1000. So here don't take LCM. 4000 plus 14 divided by 23 into 1000, you will get 608.7. So final answer is 4608.7 runs. Okay, that means maximum batsman scored 4608.7 runs. That's the meaning of mode. Exercise 13.2, question number 6. A student noted the number of cars passing through a spot on a road for 100 periods each of 3 minutes and summarized it in the table given below. Find the mode of the data. So here you can see 7 times the student observes that 0 to 10 cars pass through that point. Okay, and 14 times he observes that 10 to 20 cars pass through that point. Okay, and finally here at the last you can see 8 times he observes 70 to 80 cars pass through that point. Okay, and period they are given as 100 period. Okay, that means if you sum up all the frequencies, it will be equal to 100. Okay, so now I should find the mode of this data. Now you can see the highest frequency is 20, therefore modal class will be 40 to 50, that is the modal class. Now use the formula. Mode is given by L plus F1 minus F0 by 2 F1 minus F0 minus F2 into H. So modal class is 40 to 50, so lower limit is 40, therefore L is 40. Okay, L is 40, that is the lower limit of the modal class, plus F1 the frequency of the modal class, that is 20. This is the highest frequency also, so 20 plus minus F0, this is the frequency of the class which comes before the modal class, that is 12 here. Okay, divided by 2 into F1 is 20 minus F0 is 12 minus what is F2? F2 is the frequency of the class succeeding the modal class, that is 11 here in this case. 11 into what is H? H still we have not calculated. So H is the class width or the class size. So in the first class, what is the upper limit? Upper limit is 10, lower limit is 0. So 10 minus 0 is 10. Okay, so 10 is the class width. So we can observe that the class width is same in all the class. Okay, so into 10 here, so this is 40 plus 20 minus 12 is 8. Now 2 into 20 minus 12 minus 11, how much is that? It is 17. Okay, into 10. Now don't take LCM. 40 plus, so 8 into 10 divided by 17, you will get 4.705. so you will get 44.705. okay, this many cars. So what is the meaning of this? Mode is 44.705. so mode is the average in the model class. So in this class the average is 44.75. that means maximum number of the times that boy observed 44.7 cars passing through that point. And that completes this problem and this exercise. The next topic in this chapter is median of grouped data. So median of group data is the value of the middlemost observation in the data. Okay, and if there is n number of data and if n is an odd number, then the median is the n plus 1 by 2th observation, and if n is an even number, the median will be the average of n by 2th and n by 2 plus 1th observation. In the textbook there is one example problem. So here you can see marks obtained by 100 students has been given, and the maximum marks is 50. Okay, first row is marks and second row is number of students. So 6 students have scored 20 marks, 28 students have scored 29 marks, and so on. So to find the median, first we need to arrange all this data in columns like this. The first column is marks, second column is number of students. Number of students we can take as frequency, that is F. Okay, so totally there are 100 students. Okay, and you can make one observation that the marks obtained has been arranged in ascending order, that is 20 is the least marks obtained. Okay, and 43 is the highest marks obtained by the students. To find the median, we should calculate cumulative frequency. So this is the frequency, we should find the cumulative frequency. To find cumulative frequency, we need to make another column like this. Okay, and the first number in cumulative frequency will be the same as F1. Okay, this is frequency, this is F1, so same number comes here. And the second number in cumulative frequency will be the addition of F1 and F2, that is 20 plus 6, 26. And this we can also add 6 with this 20, that way also we can do. And the third number is 50. 50 is nothing but the sum of all these frequencies, that is 6 plus 20 plus 24, which gives 50. Or we can add 24 with 26, that also gives 50. The fourth value is 78. 78 is the sum of all these frequencies, that is 28, 24, 20 and 6. Or also if we add 28 with this 50, we get 78. Like this we should calculate the cumulative frequency, and the last value of the frequency is, you can see, it is 100. So 100 is nothing but the number of students. Okay, now we should find the median. So what is median? Median is the value of the middlemost observation in the data. Okay, so 100 students are there, so you can see 50 students. Okay, 50 students have scored marks equal to or less than 28. Okay, and the remaining 50 students have scored marks greater than or equal to 29. Okay, so 28 and 29, average of 28 and 29 will be the median. So you can see here, so 100 divided by 2 is 50. So 50th and 51st observation is 28 and 29 respectively. So if we take the average of 28 and 29, we get 28.5. So what it means? 50 students have scored marks less than 28.5, and 50 students have scored marks greater than 28.5. That's the meaning of median. There is another example in the textbook. Here you can see marks obtained by 53 students has been given. Maximum marks is 100. So 5 students have scored marks between 0 to 10. 3 students have scored marks between 10 to 20. So number of students we can take as frequency. So totally there are 53 students. So here the marks obtained is already given in ascending order. Okay. Now we should find the cumulative frequency. So cumulative frequency, I already told you how to find the cumulative frequency. So after finding the cumulative frequency, the last value is equal to 53. 53 is the number of students. Okay. Now what is half of 53? So what is the median? First of all, it is the value of the middlemost observation in the data. So I'll divide 53 by 2. If I divide 53 by 2, I'll get 26.5. Okay. And 26.5. So here cumulative frequency is 29. So 26.5 is close to this cumulative frequency. Okay. And therefore we take this as median class, 60 to 70. So 60 to 70 is the median class. And to find the median, this is the formula which we use to find median for group data. Median is equal to L plus n by 2 minus CF by F into H, where L is the lower limit of the median class. So 60 to 70 is the median class, we found it. So lower limit means 60. N is the number of observation, which is equal to 53. CF is the cumulative frequency of the class preceding the median class. So median class is this, okay, 60 to 70, and its frequency is 29, and 22 is the frequency of the class preceding the median class. Okay. And F is equal to frequency of the median class, that is 29. So and what is H? H is the class size, and after substituting all the values, we get median equal to 66.4. So what it means? So it means 50% of the students scored marks less than 66.4, and the remaining 50% students scored marks more than 66.5. Some more work examples have been given here. All are self-explanatory. Just go through it. I'll be solving exercise problems now. So here you can see the relation among median, mode and mean. So 3 times of median is equal to mode plus 2 times of mean. Exercise 13.3, question number 1. The following frequency distribution gives the monthly consumption of electricity of 68 consumers of a locality. Find the median, mean and mode of the data and compare them. So you can see that 4 consumers have consumed electricity between 65 to 85 units. 5 consumers have consumed electricity between 85 to 105 units, so on. Okay. And 4 consumers have consumed electricity between 185 to 205 units. So here we can see that the consumption, it's already arranged in ascending order. I have written the same data here. So number of consumers I can take as frequency. Okay. Now if I add up all the frequency, I'll get that to be equal to 68. That is sigma Fi is 68. So 68 is the number of consumers which is given in the question itself. Okay. Now to find the median, I should find the cumulative frequency. So cumulative frequency. So first value of the cumulative frequency is same as the frequency, that is 4, and the second value will be 5 plus 4, okay, which is equal to 9. Okay, if I add this 4 to this 5, I'll get 9. Again, if I add 9 to 13, 9 plus 13 is 22. So then 22 plus 20 is 42, and so on. Here I'll get 56. 56 plus 8, I'll get 64. 64 plus 8, I'll get 68. See here, I got 68 last one. So the number of consumer is also 68. Okay. Now I should find the mean. So to find the mean, I should find xi. Xi and xi, fi I should find. So first let me find xi. Xi is nothing but the mid value of the class interval. So in the first class interval, what is the mid value of mid value between 65 and 85? So 65 plus 85 by 2 gives 75. So 75 is the mid value. Now what is the class width or the class size? So 85 minus 65 gives 20. This is the upper limit, this is the lower limit of the first class, and 20 is the class size, that is h. Now if I add h to 75, 75 plus 20 is 95. 95 will be the mid value of the second class, plus 20 is 115. I'll get 115 is the mid value of the third class. Similarly here, plus 20 is 135, plus 20 is 155, 155 plus 20 is 175, 175 plus 20 is 195. Now to find the mean, I should find fi xi, but what is the disadvantage now? Xi are all big values. So if I multiply the frequency with these values, I'll get fi xi very big values. It's all tedious task. So I won't go for direct method. So I'll go for assumed mean method. So for that I should find d. Di is equal to xi minus a. What is a? A is the mid value of xi. So here xi, how many values are there? 1, 2, 3, 4, 5, 6, 7 values are there. So middle of middle value is 135. So 135 I'll take as a. Now 75 minus 135 is minus 60. Okay, then 95 minus 135 is minus 40. 115 minus 135 is minus 20. So here 135 minus 135 is 0. 155 minus 135, 20. So here 40, here I'll get 60. Now here also di are all not so small value, it's all big value only. So if I have to find mean by assumed mean method, I should find fi di. If I find fi di, I'll get big values. So instead I will go for step deviation method. So for step deviation method, I should find ui. Ui is equal to d by h, di by h. So my h is 20. So if I divide 20, if I divide the di column by 20, I'll get ui. So minus 60 by 20 is minus 3. Then minus 40 by 20 is minus 2. So here minus 1 will get 0 by 20 is 0, 20 by 20 is 1, 40 by 20 is 2, 60 by 20 is 3. Now I should find ui fi. So multiply frequency with ui. So 4 3s are 12, minus 12, 5 2s are 10, so here minus 10. Then 13 into minus 1 is minus 13. So 20 into 0 is 0, 14 into 1 is 14, 8 2s are 16. Okay, 4 3s are 12. Now if I sum up all the values of the last column, I'll get sigma fi ui. This I'll get equal to 14. Please cross verify it. Okay, sorry, it's 7 sigma fi ui. I'll get 7, not 14. Now what is mean given by? Mean is given by, mean is equal to a plus h into ui. So what is a? A we have taken as 135. 135 plus h. H is 20. That is the class size into ui. Ui is, what is ui? U bar. U bar is equal to sigma fi ui divided by sigma fi. So 7 by 68. So this is equal to 135. So we can simplify by dividing by 2. Is it divisible by 4? Yeah, 4 5s are 20. 4 1s are 4. 4 7s are 28. So 5 into 7 divided by 17. So you will get that to be equal to 2.058. Okay, so this is 137.0588, or this is approximately equal to 137.06. If I cancel this, I can make this, I can add one here. So 137.06 units is the mean. That means among the 68 consumers, on an average, each consumer is consuming 137.06 units of current. Coming to the mode, see here in the data you can see the maximum frequency is 20. Therefore mode class is 125 1 to 145. This is the mode class. Okay, now mode is given by L plus F1 minus F0 divided by 2 F1 minus F0 minus F2 into H. So what is L? L is the lower limit of the mode class. So 125 is the lower limit of the mode class, plus F1 is the frequency of the mode class, so that is 20, minus F0 is the frequency of the class preceding the mode class. Here it is 13. Okay, this is the mode class, so 13 is the frequency preceding the mode class. So 13 divided by 2 into 20 minus 13, and F2 is the frequency of the class succeeding the mode class. So this is the mode class, so this is the frequency which is succeeding the mode class, so minus 14. So into H is 20, so we'll get 125 plus 20 minus 13 is 7. So here you will get 13 into 20. Okay, don't take LCM, and finally you will get 125 plus 7 into 20 divided by 13, you get 10.76. So you will get 135.76 units. And coming to median, to find median we should find the median class. So what is n by 2? N is the number of consumers, so it is 68. So 68 by 2 I'll get as 34. So frequency that is close to 34 is, so cumulative frequency that is close to 34 is 42. Okay, and also 42 is greater than 34. So 125 145 we can take as median class. Okay, so substitute all the values in the formula. Median is given by L plus n by 2 minus CF by F into H. So what is L? L is the lower limit of the median class, right? So it's 125 plus n by 2 is 68 by 2, and CF is the cumulative frequency of the class preceding the median class. So 125, 140, 125, 145 is the median class, and 22 is the cumulative frequency of the class preceding the median class. So minus 22 divided by f, that is the frequency of the median class. What is the frequency of the median class? It is 20. Okay. And into h. What is h? H is 20. So here luckily this 20 and this 20 is getting cancelled. So 125 plus 68 by 2 is 34. 34 minus 22. So we'll get 137 units. Exercise 13.3, question number 2. If the median of the distribution given below is 28.5, find the values of x and y. So here frequency I'll add. So here I'll get 45 plus x plus y. Okay, if I add all this, now I will find the cumulative frequency also. So cumulative frequency, the first number will be same as the frequency. So what is the second value here? So second will be 5 plus x. The third will be 20 plus 5 plus x. So I should add these two. So 5, so it becomes 25 plus x. Fourth value will be, if I add this with 15, so it is 40 plus x. The fifth will be 40 plus x plus y, and the sixth will be 45 plus x plus y. So you can see this and this is same. Okay, the last value of cumulative frequency should be equal to the sum of the frequencies. Okay, now given median, they have given median is equal to 28.5. okay, median is equal to 28.5. so what is the formula for median? Median is equal to L plus n by 2 minus CF divided by F into H. Okay, now median is 28.5. Substitute the value 28.5 is equal to L. So what is L? Lower limit of the median, right? So since median is since median is 28.5, where is the median class? It lies here. Okay, this is the median class. So now L is 20, that is the lower limit of the median class, plus n by 2. What is n? So n is 60. Already that also it is given in the data. Okay, the sum of the frequencies total they have mentioned as it to be 60. So 60 by 2 minus CF. This is the cumulative frequency of the class preceding the median class. So that is this one. This is CF. The frequency of the class preceding the median class is CF. So that is 5 plus x. Okay, by frequency of the median class is 20. Okay, see, this is the median of the frequency of the median class. So divided by 20 into H. What is H? What is the class size? So 10 minus 0 is 10. So this is the upper limit, this is the lower limit of the first class. So h is 10, so into 10, so this is equal to 20 plus 60 by 2 is 30. So 30 minus, if I open the bracket, minus 5 minus x I will get, divided by 20 into 10. So now this is equal to 20 plus 25, 30 minus 5 is 25 minus x by, now here 0 will get cancelled, I am left with 2. Now take the LCM, 28.5 is equal to 20 plus 25 minus x by 2. So this is 28.5 is equal to, if I take LCM, it is 40 plus 25 minus x by 2. Now if I cross multiply, I will get 57 is equal to 40 plus 25 minus x. So if I take 40 to the left hand side and 25 also to the left hand side, I will get x is equal to 8 I will get. Okay. Now x is equal to 8. Now sigma fi is 60, that is 45 plus x plus y is equal to 60 given. Okay. Or x plus y is equal to 60 minus 45. So x plus y is equal to 15. So x we got as 8. So 8 plus y is equal to 15. Therefore y is equal to 15 minus 8. Y is equal to 7. Exercise 13.3, question number 3. A life insurance agent found the following data for distribution of ages of 100 policy holders. Calculate the median age if the policies are given only to persons having age 18 years onwards but less than 60 years. So this is the data. So there are two policy holders below 20 years of age. There are 6 policy holders below 25 years of age, like this. Okay. And 100 policy holders are below 60 years of age. Now with this data I have made another table, as you can see here. In the first column I have written class interval starting from age 15 to 20, this way, 15 to 20 years, 20 to 35 years, and 25 to 30 years, 30 to 35 years, 35 to 40 years, like this I have made. And the second column is same as the second column of the given data, that is number of policy holders. So here policy holders, number of policy holders are nothing but the cumulative frequency. Okay. So same cumulative frequency I have taken. Now I should find frequency. So to find the first frequency will be same as the cumulative frequency 2. Okay. And in the next class the frequency will be cumulative frequency of second one minus cumulative frequency of the first one, that is 6 minus 2. 6 minus 2 is 4. Okay. And in the third frequency will be 24 minus 6, cumulative frequency of the third minus cumulative frequency of the second. So it is 18. Similarly 45 minus 24 is 21. 78 minus 45 is 33. Then 89 minus 78 is 11. 92 minus 89 is 3. Then 98 minus 92 is 6. 100 minus 98 is 2. Okay. Now if I add all this, what should I get? I should get this value, the last value of the cumulative frequency, sigma fi. 2 plus 4 plus 18 plus 21 plus 33 plus 11 plus 3 plus 6 plus 2 is 100. Okay, you can cross verify and check it. Now I should find the median. Okay, so median median is equal to L plus n by 2 minus cumulative frequency divided by frequency into h. What is the class size? You can see class size is 5. Okay, so if you consider the first class interval here, 20 minus 15 is 5. 5 is the class size h, the upper limit. This is the lower limit of the first class. Okay, now median. So what is L? So L, we know n is equal to 100. That is the sigma fi is 100. That only is n. Okay, n by 2. So n by 2 is 100 by 2, which is equal to 50. Okay, now where this 50 close to cumulative frequency, so this column is cumulative frequency. So here you can see 50 is close to this value 78. Okay, 50 is close to 78 and less than 78. Okay, therefore this is the median class. Okay, now L is the lower limit of the median class, that is 35 plus n is 100 by 2 minus cumulative frequency of the class preceding the median class, that is 45. Okay, always this cumulative frequency is not the cumulative frequency of the median class, it's the cumulative frequency of the class preceding the median class. So by f, now f is the frequency of the median class, that is 33 into h is 5. So this is equal to 35 plus 50 minus 45 by 33 into 5. So this is equal to 35 plus 5 by 33 into 5. So don't take LCM. So this is 35 plus 5 5s are 25. 25 divided by 3, you get 0.757. So this is equal to now 35.757, or approximately it is equal to 35.76. Okay, can cancel this and add 1 here. So 35.76 years. So 50 is close to 78 and less than 78. Therefore median class is 35-40. Okay, 35 to 40, this is the median class. Okay, exercise 13.3, question number 4. The length of 40 leaves of a plant are measured correct to the nearest millimeter, and the data obtained is represented in the following table. Find the median length of the leaves. So in the first column, length of the leaf in millimeter is given. In the second column, number of leaves is given. So here there is also a hint. The data needs to be converted to continuous class for finding the median, since the formula assumes continuous classes. The classes then change to 117.5, 126.5, 126.5, 135.5. So like this we should change. So here here it is not continuous. You can see 1182, 126. The next class is not starting from 126, it is starting from 127. Similarly, the upper limit is 135. So again third class, it is not starting from 135. So if it is like this, it's not continuous. So continuous class means the upper limit of one class will be the lower limit of the next class. That way it's going to be. So we should convert this to continuous class. Okay, so the first class we should take 117.5 to 126.5. Therefore second we can take 126.5 to 135.5. Okay, so after doing all changes, the new data is like this. I have written here, you can see. And the number of leaves I can take as frequency, and given that it's data of 40 leaves, therefore if I sum up all the frequencies, I should get sigma fi as 40. Okay, now let me calculate cumulative frequency. So first value will be the same as the frequency. The second cumulative frequency will be 5 plus 3, 5 or 3 plus 5, 3 plus 5 is 8, then 8 plus 9 is 17, like this. Now 17 plus 12 is 29, 29 plus 5 is 34, 34 plus 2, 34 plus 4, 38, and 38 plus 2 is 40. Now you can see this value and this value should be equal. The last value of the cumulative frequency should be equal to the sum of the frequency. So this is also equal to n. Okay, now what is n by 2? N by 2 is 40 by 2. N is nothing but the frequency. Now 40 by 2 is 20. Okay, now which cumulative frequency is closer to 20 and less than 20? This one. Okay, this is the median class. Okay, n by 2 is closer to 29 and less than 29. That's why this one will take as median class. Now median is given by L plus n by 2 minus Cf by f into h. So what is L? L is the lower limit of the lower limit of the median class, that is 144.5. So 144.5 plus n by 2, that is 40 by 2, minus cumulative frequency. So this cumulative frequency is the frequency of the class preceding median class. So it is 17 divided by frequency of the median class. Frequency of the median class is 12. Okay, don't take 29. 29 is cumulative frequency, divided by 12 into what is h. Now h, considering the first median class, upper limit is 126.5, lower limit is 117.5. So if you subtract, this is the upper limit, this is the lower limit, so 0, then it is 16 minus 7, 9. So 9, h is 9. So this is 144.5 plus 20 minus 17 by 12 into 9. So this is 144.5 plus 20 minus 17 is 3. 3 by 12 into 9. Now 3 1s are 3, 3 4s are 12. So 9 divided by 4. Don't take LCM now here. 144.5 plus 9 divided by 4, you get 6 point, sorry, it's 2.25. So this is will get 146.75, this many millimeter. So what it means, 50% of the leaves have length below 146.75 and 50% of the leaves have length more than 146.75. Exercise 13.3, question number 5. The following table gives the distribution of the lifetime of 400 neon lamps. Find the median lifetime of the lamp. Okay, so first column is the lifetime in hours. So 14 lamps, 14 lamps have lifetime of 1500 to 2000 hours. 56 lamps have life between 2000 to 2500 hours, and so on. Okay, now I should find the median. So to find the median, what should I do? First find the median class. To find the median class, I should find first cumulative frequency. So what is the first value of the cumulative frequency? It is 14, same as the frequency. Second cumulative frequency will be 14 plus 56, I'll get 70. Then 70 plus 60, I'll get 130. Then 130 plus 86, 216. Okay, 216 plus 74, I'll get 290. 290 plus 62, I'll get 352. Then 352 plus 48, I'll get 400. So last value is 400. Also they have told the data is for 400 lamps, and when we sum up here, sigma f will get us 400. Okay, now what is n? N by 2. N by 2 is equal to 400 by 2, which is equal to 200. Okay, so n by 2 lies close to 216 and is less than 216. Okay, therefore this is the median class. Okay, this is the median class. Therefore median class is 3000 to 3500. Okay, now what is median? Median is equal to L plus n by 2 minus cumulative frequency by f into h. So this is equal to 3000 plus n by 2, that is 400 by 2 minus cumulative frequency. So cumulative frequency, this is not the cumulative frequency of the median class, this is the cumulative frequency of the class preceding the median class, that is 130. Okay, 130 minus frequency of the median class. So it's not 216, don't confuse here. Take 86 into 500. So this is equal to 3000 plus this is 400 by 2 is 200. 200 minus 130 by 86 into 500. So this is 3000 plus 200 minus 130, 70 by 86 into 500. So this will get 3000 plus 70 by 86 into 500, you will get 406 406.98 you will get. So when we add, we get 3406.98, and we can approximate to 3407. So this is approximately equal to 3407 hours. Okay. So what does this median means? So 50% of the bulbs have lifespan lesser than 3407 hours, and 50% of the bulbs have life more than 3407 hours. Exercise 13.3, question number 6. 100 surnames were randomly picked up from a local telephone directory, and the frequency distribution of the number of letters in the English alphabets in the surnames were obtained as follows. Determine the median number of letters in the surname. Find the mean number of the letters in the surnames. Also find the model size of the surnames. So many people will have surname along with their name, and surnames were picked up, and it was checked, and they found that some surnames had 1 to 4 letters, some surnames had 4 to 7 letters, like this. 40 names had 7 to 10 letters, and four surnames had 16 to 19 letters. So we should find the mean, median, and mode of this data. So same data I have written here in column wise, and first column has a number of letters, second column has a number of surnames. So number of surnames is frequency. Okay, now if I add all the frequency, I will get sigma f, which is also equal to n. So this is 100 I'll get. Okay, and 100 surnames already they are given in the data itself, and now I'll find x. Okay, sorry, xi. So what is xi? Midpoint of the class interval. So for the first class interval, what is the midpoint? 1 plus 4 divided by 5 divided by 2 is 5 divided by 2 is 2.5. So 2.5 is the midpoint of the first class interval. So now what is the class size? 4 minus 1. This is the upper limit, this is the lower limit of the first class. 4 minus 1 is 3. Okay, now if I add this 3 is the class bit. If I add class bit to the first midpoint, I'll get 2.5 plus 3, I'll get 5.5. So 5.5 will be the midpoint of the second class. Now plus 3 is 8.5, plus 3 is 11.5, plus 3 is 14.5, plus 3 is 17.5. 17.5 is the midpoint of the last class interval. Now I should find D. Okay, now can I find fi xi? Fi xi, can I find it? So here I'll get big values if I find fi xi. So I won't go for a direct method to find the mean. Instead I'll go for assumed mean method or by step division method. So di is equal to xi minus a. So what is xi minus a? So what is a now? So 1 2 3 4 5 6, there are 6 values in x. So third and fourth are the mid values. Out of this I'll take third one as a. Okay, now di is equal to xi minus ai. Sorry, di is equal to xi minus a. Therefore 2.5 minus 8.5 is minus 6. So 5.5 minus 8.5 is minus 3. So 0. 8.5 minus 8.5 is 0. 11.5 minus 8.5 is 3. And here I'll get 6, here I'll get 9. Now all the values in di are divisible by 3. 3 is also the class size. So I'll find ui. Ui is equal to di by h. So minus 6 by 3 is minus 2. Minus 3 by 3 minus 1. So 0. Here I'll get 1. 6 by 3 2. 9 by 3 is 3. Now I'll sum up all this. I'll get sigma fi ui. So here it is minus 6. sum of all these values in the last column is -6. So what is mean according to step division method? So mean is given by x bar is equal to a plus h into u bar. Okay, so what is a? A is 8.5. we have taken 8.5 plus h. H is the class width, that is 3, into what is ui? Ui is sigma fi ui by sigma f. Sigma fi ui by sigma fi is u bar. So 8.5 plus 3 into sigma fi ui is -6, and sigma fi is 100. Okay, now this is equal to 8.5 minus, so here 3 into -6 by 100, I'll get negative value, which is equal to minus 0.18. So this is equal to 8.32. So mean is 8.32. Next, what is mode? Okay, mode is given by L plus f1 minus f0 by 2f1 minus f0 minus f2 into h. So in the frequency, what is the maximum frequency? Maximum frequency is 40. Okay, max frequency is 40. Therefore modal class is 7 to 10. This is the modal class. Okay, so substitute all the values. So what is L? L is the lower limit of the modal class, that is 7 plus f1. F1 is the frequency of the modal class, that is 40, minus f0 is the frequency of the class preceding the modal class, that is 30, divided by 2 into 40 minus 30 minus f2. What is f2? F2 is the frequency of the class preceding the modal class, that is 16. So into h. What is h? H is 3. So if you evaluate this one, you will get 7.88 letters. Okay, now to find the mean, I should find the cumulative frequency. So cumulative frequency, first value will be same as the frequency. Second value will be 30 plus 6, 36. Then 36 plus 40, it is 76. Then 76 plus 16, 76 plus 16 I'll get 92. Then 92 plus 4 is 96. Then 96 plus 4 again 100. So here you can see last value will be equal to n, or sigma f5. Okay, now what is the modal class? So n by 100. Okay, n by 100 is how much? So n by 2. N by 2 is 100 by 2. 100 by 2 is 50. Okay, so n by 2, where it lies? Here. Okay, I'll write here. N by 2 lies close to cumulative frequency 76. Okay, see here, n by 2 is close to cumulative frequency 76. Okay, and also it is less than 76. So this is the condition. It should lie, n by 2 should lie close to cumulative frequency of any of the cumulative frequency, and it should be less than that cumulative frequency. So this one. So this will be the median class. Median class. So luckily this was also the model class. Okay. Now what is the formula for median? So median is equal to L plus n by 2 minus cumulative frequency by frequency into h. So what is L? L is the lower limit of the model median class, that is 7. Here again 7 plus n by 2. N by 2 is 100 by 2. 100 by 2 minus cumulative frequency of the class preceding the model class. So this is the model class. So 36 is the cumulative frequency of the class preceding the model class, minus 36 divided by frequency of the model class. Frequency of the model class is 40. So 40 into h is 3. So if you evaluate, you will get 8.05. Exercise 13.3, question number 7. The distribution below gives the weights of 30 students of a class. Find the median weight of the students. So here weight is given, number of students is given. That means 2 students are weigh between 40 to 45 kg. 3 students weigh between 45 to 50 kg. So and so on. 2 students are weighing about 70 to 75 kg. So same data I've written in column. So here 30 students are there. So if I add the number of students, so this will be the frequency. Okay. So if I add the number of students, it will be equal to 30. Okay. This is sigma fi. This is also equal to n. Okay. Now what is cumulative frequency? First number will be the same as the frequency. Next 2 plus 3. 2 plus 3 is 5. 5 plus 8 is 13. So 13 plus 6 is 19. 19 plus 6 is 25. 25 plus 3 is 28. 28 plus 2 is 30. So here also you can see this will be equal to n. Okay. Now I should find the median. So n is equal to 30, right? Therefore n by 2. N by 2, how much? 30 by 2 is equal to 15. Okay, is close to cumulative frequency 19. So here, and less than 19. So always n by 2 should be close to any of the cumulative frequency, and also it should be less than that cumulative frequency. Only at that point, only that class I can take as median class. So median class will be 55 to 60. Okay. Therefore 55 to 60 is the median class. Now median is equal to L plus n by 2 minus CF by F into H. So what is L? Lower limit of the median class, that is 55. Okay, plus n by 2 is 30 by 2 minus CF. This is the cumulative frequency of the previous class preceding the previous class, that is 13 here, divided by frequency of the median class. So frequency of the median class is 6 here into H. So what is the class width or the class size? So 45 minus 40. So this is the upper limit and this is the lower limit of the first class. So it is 5. So this is equal to 55 plus 30 by 2 is 15. 15 minus 13 by 6 into 5. So this is equal to 55 plus 15 minus 13 is 2. Okay. 2 by 6 into 5. Here 2 ones are 2, 2 threes are 6. So 5 by 3. So this is equal to 55 plus 5 by 3 gives 1.666. So answer is 56.66, or you can approximate to 666, you can approximate to 56.67, and it's in kg. So half of the students are below 56.67 kg and half of the students are above 56.67 kg. The next topic in this chapter is graphical representation of cumulative frequency distribution. If we plot cumulative frequency versus the upper limit of the class interval, we get smooth curve like this, which is called as less than ogive. And if we plot cumulative frequency versus the lower limit of the class interval, we get curve like this, which is called more than ogive. And if we plot more than ogive and less than ogive in the same graph, those two curves will meet at one point, and that point is nothing but the median of the given data. Okay, see here in this example, in table 13.7, there is some data here. The class interval is this, and number of shop is nothing but the frequency. And next, cumulative frequency has been calculated. Now when we plot this, okay, so first if we plot less than ogive, it will be like this. In the first class interval is 5 to 10, so upper limit is 10, and the corresponding cumulative frequency is 2. So 5 comma 2 is this point, okay, and 15 comma 14, upper limit of second class interval is 15, cumulative frequency is 14. So 15 comma 14 is this point. Similarly 20 comma 6 is this point, 25 comma 20 is this point, then 30 comma 23, then 35 comma 27, then 40 comma 30. When we join all these points, we get less than ogive. And similarly, if we plot the lower limit versus the cumulative frequency, we get more than ogive. These two curves will meet at this point, and this point is the median of the given data. Next is exercise 13.4, question number 1. The following distribution gives the daily income of 50 workers of a factory. Convert the distribution above to a less than type cumulative frequency distribution and draw its ogive. So daily income in rupees is given in the first row. In the second row, number of workers is given. So this one I have written in column wise. So here you can see for 12 workers will get income between 100 to 120 rupees. 14 workers will get income between 120 to 140 rupees. Similarly, going so on, 10 workers are getting daily income of 180 rupees to 20 rupees. So now here I'll calculate the cumulative frequency. Now number of workers I'll take as frequency at cumulative frequency. Now first number in the cumulative frequency will be same as frequency, that is 12. Okay, now the second number in cumulative frequency will be 12 plus 14, that is 26. Next 26 plus 8 is 34, like this. Now 34 plus 6 is 40. So 40 plus 10 is 50. So in the question, was it given 50 workers? Yeah. So the following distribution gives the daily income of 50 workers. So I got 50 here. So whatever cumulative frequency I calculated is correct. And also if you sum up all the workers, it should be 50. Okay, this will be sigma f5, which is also equal to n. Now I should plot. So you can make another table if you want. Daily income versus cumulative frequency. So less than see here in the given table, what can you understand in the given table? So there are 120 there are 12 workers who earn less than 120. Okay, similarly there are 26 workers who earn less than 140, and similarly there are 34 workers who earn less than 160, and there are 40 workers who earn less than 180, and there are 50 workers who earn less than 200. So you can make another table like this. Less than 120 there are 12 workers, and less than 140 there are 26 workers, and less than 160 there are 34 workers, and less than 180 rupees there are 40 workers, and earning less than 200 rupees there are 50 workers. Okay, now I should plot this in the graph. So from first table only directly you can plot it. Okay, we should plot the upper limit. Upper limit here are 120, 120, 140, 160, 180, 200. All these are upper limits. So here also you can see its upper limit. Okay, so directly from table 1 also you can draw the graph. Now you can see I have made a rough plotting of the data on a graph sheet. In the x-axis I'll take the upper limit of the class interval. What is the upper limit? 120, 140, 160, 180, 200, right? So you can see upper limit 100, 120, 140, 160, 180, 200. And in the y-axis we will take cumulative frequency. Cumulative frequency is 12, 26, 34, 40 and 50. This is 10, 20, 30, 40, 50. Okay, for upper limit 120 we got cumulative frequency 12, so that point is here. For upper limit 120 cumulative frequency is 12. For upper limit equal to 140 cumulative frequency is 26. This one for 140 it is 26. For 160, for upper limit 160 cumulative frequency is 34. Similarly for upper limit equal to 180 cumulative frequency is 40. For upper limit equal to 20 cumulative frequency is 50. After this plotting all these points, I'll join all these points, I'll get a smooth curve. So this is a rough graphical representation. We'll see how really on a graph it's going to look. The first step that we do in graphing plot is we should draw the x and y axis. So this is the x-axis and this is the y-axis. We should name it. So you can see now I have named the axis. This is x-axis, and x-axis will be the income in rupees, and y-axis will be the number of workers. So after this I should take a proper scale and I should name all the units here. I should give the values for all the units here. So now you can see that I've taken scale for x-axis as 1 centimeter is equal to 1 unit is equal to 20 rupees. That means each and every unit is equal to 20 rupees here. Okay, so this is 100 to 120, 120 to 140 rupees and so on. And y-axis I have taken 1 unit is equal to 10 workers. So it is from here to here it is 10 workers. Now I should plot all the points. See, for upper limit 120 we got cumulative frequency is 12. So here also it is same thing. For upper limit 120 we got cumulative frequency 12. So we'll plot that point first. Okay, for 120 cumulative frequency is 12. So this is 10, this is 11, this is 12 here. Okay, and for upper limit 140 we got cumulative frequency 26. Okay, so that point is here. For 140 cumulative frequency is 20. This is 25, this is this is 20, this is 25, and what, this is 26. Okay, and for upper limit 160 For upper limit 160, cumulative frequency is 34. So for 160 it is 34. This is 30, this is 34. Okay, 30, 34. And for upper limit 180 we got cumulative frequency equal to 40. So that point is here. And for upper limit 200 we got cumulative frequency equal to 50. So after this I'll join all these points. So it should not be a straight line, it should be a smooth curve. Okay, you should draw in your hand itself. So I'm using some kind of online tool. So okay, this is the less than type ogive. So marking all the x-axis, y-axis properly, and giving all the units, taking proper scale and drawing the smooth curve. Everything carries marks, and everything you should do using scale and pencil only. I am using some kind of online application. So in examination I think you may have to use graph sheet for this purpose, and that completes this problem. Exercise 13.4, question number 2. During the medical checkup of 35 students of a class, their weights were recorded as follows. So in the first column weight is there, in the second column number of students is there. So there are 0 number of students who weigh less than 38 kg. There are 3 number of students who weigh less than 40 kg, and so on. And there are 35 students who weigh less than 52 kg. Draw a less than type ogive for the given data. Hence obtain the median weight from the graph and verify the result by using the formula. So I have written the same data here. Now you can see the number of students is nothing but the cumulative frequency. Okay, now how many students are there whose weight is between 38 to 40? Okay, so below 40 there are 3 students. Okay, therefore between 38 to 40 kg there are 3 students. Okay, so and between 40 to 42, so there are 5 minus 3 is 2. Okay, there are 2 students who weigh between 40 to 42 kg, and again there are 42 to 44. Okay, now 9 minus 5 is 4. So there are 4 students who weigh between 42 to 44 kg. Similarly 44 to 46. 14 minus 9 minus 9 is 5. There are 5 students who weigh between 44 to 46 kg. Similarly 28 minus 4 is 14. Okay, there are 40 students who weigh between 46 to 48 kg. Similarly 48 to 50. 32 minus 28, there are 4 students who weigh between 48 to 46 kg, and similarly there are 3 students. There are 3 students who weigh between 50 to 52 kg. Okay, now I'll take this as class interval, and whatever I got here in the second column of the new chart is, this will be the frequency. Okay, now if I add all this will be the sigma fi, which is equal to 35. Okay, 3 plus 2 plus 4 plus 5 plus 14 plus 4 plus 3, I'll get 35. Okay, and below this I'll write the cumulative frequency also. So here it is 3, then 3 plus 2 5, then it is 9, 14, 28, 32 and 35. Okay, this cumulative frequency will be the same as the cumulative frequency given in the question. Now this table I can use to draw the ogive of the less than type. So let us roughly draw the less than ogive type. It's given in the question. Draw less than ogive type has been asked in the question. So in the x-axis I have taken the upper limit of the class interval, and in the y-axis I have taken cumulative frequency. So we can use any of these two tables, this or this, to plot the less than ogive. So you can see for 3 students are less than 40 kg, right? So for 40 it is 3, and 5 students are less than 42 kg. So for 42 it is 5. So you can use this data also, 3 and upper limit here, 5 and 42 like this. And for 44 it is 9. So for 44 it is 9 here. And for 46 it is 14. For 46 14 is here. And for 48 it is 28. 48 is 20, and 25, it's 28 somewhere here. And for 50 it is 32. For 50 it is 32 somewhere here. And for 52 it is 35. Okay, for 52 it is 35. Now I'll join all these points. So not scale, it should be freehand. And now you can see that's a smooth curve. Okay, so now this is less than ogive type, less than ogive type. Okay, but in the question what they have asked, hence obtain the median weight from the graph. To obtain the median weight from the graph, we should draw the more than ogive graph also. So to do that I should make another table. Now you can see here there are 3 students who are more than 50 kg. Okay, see here you can check, there are 3 students who are more than 50 kg. So more than 50 kg there are 3 students. Okay, and more than 48 kg there are 3 plus 4 7. There are 7 students who are more than 48 kg. Similarly, more than 46 kg there are 3 plus 4 plus 14, or 7 plus 14. 7 plus 14 is 21. Okay, there are 21 students who are more than 46 kg. Similarly, you can observe that more than 44 kg, sum of all this 5 plus 14 plus 4 plus 3, you will get 26. There are 26 students who are more than 44 kg. Similarly, more than 42, you get 4 plus 5 plus 14 plus 4 plus 3, which is equal to 30. There are 30 students who are more than 42 kg. Similarly, there are 32 32 students who are more than 40 kg, and there are 35 students who are more than 38 kg. Okay, 38 kg. So now using the last chart, I will plot the more than ogive. Okay, the last column is cumulative frequency. Now in the last chart you can see 38, 40, 42, these are all the lower limits of the class interval which we got here. Okay, now for 38 the cumulative frequency is 35. So for 38 it is 35. See here, I'm plotting that point. For 38 it is 35. For 40 it is 32. For 40 it is 32. That point is here. And for 42, observe the last column, last chart. For 42 we have point 30. For 42 it is point 30, it is here. And for 44 it is 26. 44 it is 25, it is 26 here. And for 46 it is 21. For 46 it is 21, somewhere here. And for 48 it is 7. For 48 it is 7. Okay, somewhere here. And for more than 50 we have 3 students. There are 3 students who weigh more than 3 kgs. Sorry, there are 3 students who weigh more than 50 kgs. Okay, now I'll join all these points. This is a freehand sketch. Okay. Now here these two arcs are meeting at this point. From here I will draw one perpendicular to the x-axis. Okay, this point is median. So this is a just rough sketch. Exactly when we draw on graph sheet, we'll get the exact value of the median. Okay, this is more than ogive. Okay, now let us practically plot these values on graph sheet and find the actual median. And also they are told to verify the result by using the formula. So both also will do. My electronic notepad has some tolerance in it, and that's why I'm not able to draw this curves passing through all these points. However, this curve has come perfectly. Let us see how we can do this practically on a graph sheet and get it correctly. So let us now practically draw the ogive on a graph sheet. So the first thing that we should do is draw the x and y axis. So this is the x axis, this is the y axis. So using a scale and pencil you should draw. I am using some online tool. So x axis I'll take weight in kg, and in y axis I'll take the number of students. So here this is nothing but the cumulative frequency, whatever comes in y axis, and in the x axis it is the lower and upper limit of the class interval. Okay, now you can see I have chosen scale. X axis I have chosen 1 unit is equal to 2 kg. That means from here to here it is 2 kg, from here to here it is 2 kg, from here to here it is 2 kg, from here to here it is 2 kg. Starting from 38 up till 52 I have taken, and y axis I have taken 1 unit is equal to 10 number of students. That means from here to here there are 10 students, from here to here it is 10, 10, 10 like this. So it is 10, 20, 30 and 40. So, and in the first chart, this chart you can see there are 3 students who are less than 40. Okay, so I'll plot that point here. So there are 3 students who are less than 40. So 40, that is 40 comma 3, that point is here. Okay, and next is there are 5 students who are less than 42. We can take here also, there are 5 students who are less than 42. So for less than OG, you should take the upper limit. So there are 5 students who are less than 42. 5 students less than 42. So 42 comma 5 I should plot. So this is 42, this is 5, this is 42, 5. Next is for 46. So here you can see there are 9 students who are less than 44 kg. So 9 students who are less than 44. Okay, here there is one small mistake. Okay, there are 9 students who are less than 44 kg. That point is here, and there are 14 students who are less than 46 kg. So 46 comma 14 is here. So this is 10, this is 15, 1 point below that, this is 14. And for 48, there are 28 for 48. So there are 28 students for less than 48 kg. So this is 20, this is 30, 2 points lesser than that, this is 28. Okay, second, this is this point. Okay, and there are 35 students who are less than 52 48, 50, okay, sorry, 32 students who are less than 50 kg. So that point is here. 32 students, this is 30, this is 1, this is 2. Okay, there are 32 students who are less than 50, and there are 35 students who are less than 52. 35 students less than 52, that point is here. Now I'll join all these points using a smooth curve. Okay, let me do it. So this without using scales, you should not use scale. You should just use your pencil and draw it in free hand. Okay, this is less than ogive. So now I should draw the more than ogive. For that I can use this last chart. So there are 35 students who are more than 38 kg. So more than 38 kg, there are 35 students. So the 38 comma 35 is here, and next is there are 32 students who are more than 42 kg. So 32 comma 40 comma 32 I should draw. Okay, 40 comma 32. 40 is 31, this is 32. Okay, next is 42 comma 30. Okay, 42 comma 30, that point is here. Then next is there are 26 students who are more than 44 kg. So 44 comma 26 I should plot. 44 comma 26. So 44 and 20, 25. This is 25, this is 26. Next is there are 7 students who are more than 48 kg. So 48 comma 7. So this is what about 46? Okay, there are 21 students who are more than 46 kg. So 46 comma 21. So 46 comma 21, this is 46, this is 20, 21. Okay, and there are 7 students who are more than 48 kg. So 48 comma 7, 48, this is 5, 6, and 1 point above, this is 7. Okay, next there are 3 students who are more than 50 kg. So more than 50, there are 3 students. This is 1, 2, and this is 3. Now again, using scale, draw using only pencil, draw a smooth curve with your hand only. Don't use scale, just pen using your hand. Oh. Okay, this is the more than ogive. Now you can see this less than and more than ogive meet at this point. Okay, now from this point, if I draw a perpendicular to the x-axis, whatever value I'll get in the x-axis will be the median. So let me do so. So this is that point. I'm drawing perpendicular to x-axis. Okay, I'm getting as 47. So 47 is the median. Oh, sorry, it's not 47. I misread it. So 47 is here, between 46 and 48, 47 is here. So this point is actually 46.4. Okay. So this point V, coordinates of point V is 46.4 comma 0. Okay, so median is 46.4 according to this graph. Okay, in graph we won't get accurate value. Okay, let us cross verify using the formula method. So here you can see I have written median is equal to 46.4 kg according to graph. Let us verify using formula method. Here you can notice one thing, that to draw the less than ogive, we need to consider the upper limit of the class interval and the cumulative frequency. Okay, but to draw the more than ogive, we need to consider the lower limit of the class interval and the cumulative frequency. This cumulative frequency is different from this cumulative frequency. Okay, to find the median using formula method, we need to find what is n by 2. So n by 2, n is nothing but the sum of the frequencies, that is sigma fi. So that is 35 by 2, 35 by 2 I'll get as 17.5. Okay, therefore n by 2 is close to cumulative frequency 28. Okay, see here you can see in the middle chart, you can see the cumulative frequency is 28. So n by 2 is close to 28 and less than 28. Okay, therefore the median class is this one, 46, 48. This is the median class. Okay, therefore median class is 46, 48. Okay, now the formula for median is L plus n by 2 by minus Cf by F into H. So what is L? L is the lower limit of the median class, that is 46 plus n by 2, that is 35 by 2 minus cumulative frequency. So this is the frequency of the class preceding the median class. So median class is this 14. So 14 is the frequency of the class preceding the median class. So 14 divided by f is the frequency of the median class. So 14 is the frequency into h. What is h? H is 2. Okay, upper limit of first median class, upper limit of first class interval is 40, the lower limit is 38, so this is 2. So upper limit minus lower limit gives h. So this is 46 plus 35 by 2 is 17.5 minus 14 divided by 14 into 2. So here 2 ones are 2, 2 sevens are 14. So this is 46 plus 17.5 minus 14, 14, 15, 16, 17. This is 3.5, 3.5 by 7. So 7 ones are 7, 7 fives are 35. So 0.5. So 46 plus 0.5. This is 46.5 kg is the median. Okay, see, in formula method we got 46.5 as the median, but in graph we got as 46.4 kg. It's the answer is very close. Okay, in graph method always there will be some error. Okay, while plotting the points and while drawing the smooth curves, there will be some minor errors. That's why we won't get correct value, exact value from the graph. So from median method, from formula method, we get exact value, and that completes this problem. Exercise 13.4, question number 3. The following table gives production yield per hectare of wheat of 100 farms of a village. Change the distribution to a more than type distribution and draw its ogive. So first row it is a production yield, which is in kg per hectare. Second row is the number of farms. So there are 2 farms whose output is 50 to 55 kg per hectare. There are 8 farms whose output is 55 to 60 kg per hectare, and so on. And there are 16 farms whose output is between 75 to 80 kg per hectare. So same data I have written here in vertical columns. Now I should convert this to more than type distribution. So now number of farms will be the frequency. Okay, now if I add all these frequencies, I will get 100. Okay, so this is sigma fi, or this also equal to n. Now I should draw the more than type distribution. Now here I will write more than 50. Okay, more than 50 kg per hectare. So how many is that? That will be equal to 100. This is the cumulative frequency. So since n is 100, since n is 100 farms are there whose output is more than 50 kg. Okay, then 100 minus 2, 100 minus 2 is 98. There will be 98 farms whose output is more than 55 kg. Okay, then similarly there will be now 98 minus 8 is 90. So there are 90 farms whose output is more than 12, whose output is more than 60 kg. And now 90 minus 12 is 78. So there will be 78 farms whose output will be more than 65. Now again 75 minus 24 is 54. Okay, there will be 54 farms whose output is more than 70 kg. Now 54 minus 38 you will get 16. Okay, there are 16 farms whose output is more than 75 kg. Okay, now again okay, now here you can check that the all these numbers are the lower limit of this class interval. Okay, So for more than ogive, we should consider lower limit and the cumulative frequency. These two data we should plot on a graph. Now let us first draw the rough graph before going for actual graph. So in the x-axis I will take I'll take the lower limit of the class interval, that is 50, 55, 60, 65, 70, 75, and in the y-axis I'll take the cumulative frequency. Okay, this is lower. Okay, now you can see for lower limit 50, the cumulative frequency is 100. So for 50 it is 100 here, and for lower limit 55 it is 98, so it is somewhere here. Okay, and for 60 it is 90. Okay, for 60 it is 90, it is somewhere here, and for 65 it is 75, 65, this is 78, somewhere here, and for 70 it is 54, 70, 50, 54, somewhere here, and for 75 it is 16, so somewhere here. So now I'll join all these points. So and this is the more than ogive. So now let us proceed and do the actual graph plotting. This is production yield, and this is number of farms. My electronic notepad has some tolerance, that's why this line is not passing through these points exactly, so it is supposed to pass through these points exactly. So we'll plot it on real graph and check how it looks. The first step that I'll do in drawing the graph is plot the x and y axis. This is the x axis, this is the y axis, then name it. All drawing and naming should be done using a pencil and a scale only. So x axis I am taking production yield, y axis I am taking number of farms. Now I should give a proper scale for x and y axis. Now you can see I have chosen this scale. X axis I have chosen 1 centimeter is equal to 1 unit is equal to 5 kg per hectare. That means each unit is 5 kg per hectare. From here to here it is 5 kg, here to here it is 5 kg per hectare, like this. And y axis 1 unit I have taken as 20 farms. So from here to here it is 20 farms, from here to here it is 20 farms, like this. So 20, 40, 60, 80, 100, it goes like this. Now you can see that there are 100 farms which gave yield of more than 50 kg per hectare. So what is that point here? Okay, 100 farms gave more than 50, so 50 comma 100, that point is here. Okay, that is this 50, 100. Next is 55, 98. So for 55, 98, this is 80. Okay, this is 90, 98 is here. Okay, and the next point is 60, 90. Okay, so that is 60 and 90. 60, this is 90. It is the next point, that is 65, 78. That is 78 farms gave output more than 65 kg per hectare. So 78, 65, 78. So 65, this is 60, 60, this is 70, 70. So 70, 20, 70, 78 is here. Okay, and then the next point is 70 54. So 70, so this is 40, this is 50, this is 52, this is 54. Okay, and for the third last one, for 75 it is 16, 75 is 16, this is 10, 10 12 14 16, so that point is here. So there are last one is there are 16 farms which give output more than 75 kg per hectare. Okay, now I'll join all these points. So I should not be using any scale here, only using pencil I should be drawing. So let me start from here. So it should be a smooth curve joining all the points. So this is the more than ogive. So that completes this question and this exercise. The next topic in this chapter is summary. So in group data, the mean is given by this formula, sigma fi xi by sigma fi, where f is the frequency and x is the mid value of the class interval. And if f and x are large, then multiplying f by x becomes a tedious task and it is prone to errors. So we can go for assumed mean method. In assumed mean method, the mean is given by a plus sigma fi di by sigma fi. Sometimes even d may be large, so calculating fi di also becomes tedious task. So we can go for step division method. Here it is given by a plus sigma fi ui by sigma fi into h. So in all the three methods, whether it's direct method or the assumed mean method or the step division method, we get the same value. Okay, but these two methods are very simple to calculate because we get small values, and the mode of the group data is given by L plus f1 minus f0 by 2f1 minus f0 minus f2 into h, where symbols have their usual meanings. So we have done several problems regarding mean and mode and also median. So and the cumulative frequency of a class is the frequency obtained by adding the frequencies of all the classes preceding the given class, and median is given by this formula L plus n by 2 minus Cf by f into h, where the symbols have their usual meaning. Okay, several problems we have already done it, and you can see we can draw the graph of cumulative frequency versus the upper limit of the class interval. When we do so, we get curve like this. This is called less than type ogive. And if you plot the cumulative frequency versus the lower limit of the class interval, we get graph like this, which is called more than type ogive. And if we draw both the graph, that is less than type and more than type curve, those two curves will meet at one point, and from that point if we draw a perpendicular touching the x-axis, then that point is nothing but the median of the given group data. And that completes this summary and this chapter.